morning, my name is Kai Arne, I'm the CEO of MariaDB Foundation. It's my great pleasure to wish you all a good morning and welcome to the return of the Unconference, and specifically today to the MariaDB ServerFest. So we've been meeting here at Innopoli in Finland since Monday. First an internal meeting, then we've had Unconference for 2 days, working together, getting stuff done with our community, and also broadcasting presentations yesterday, mostly then yesterday being highly technical presentations directed at those who develop the server itself. Today we're turning ourselves towards those who use MariaDB. Of course, you yourself are developers. We sometimes make a distinction between users and developers. So we have a packed program today. A couple of presentations are pre-recorded because this is in Finland, and yes, it's post-pandemic, so we're finally able to do these unconferences again, sitting together, reviewing code, working together, but we still want to have the best of the virtual aspects, so some of those who do not feel the necessity to travel across the Atlantic, for instance, can present remotely. And then we have a live audience here with those who have been participating in the meetings so far. There's an announcement that we made yesterday that I'd like to repeat now orally. And it's something that's very visible here on a poster next to me here. So we are grateful to our sponsors. We're always grateful to our sponsors. That's what any foundation is. But we now have a new one mentioned as the first sponsor. It is actually our first diamond level sponsors. It's Amazon AWS, who have joined the lineage of MariaDB Foundation sponsors. That's a great piece of news for MariaDB Foundation and for the MariaDB ecosystem as a whole. Amazon represents a lot of users and a lot of experience, and we're happy to be working more closely with Amazon in all aspects. They are already our second biggest contributor after the obvious MariaDB PLC as code contributor. So, as I said, we have a packed program. I think there's no further reason to go into the details of walking it through. I hope you will watch all of the presentations, and there are Q&A sessions. Without further ado, let's proceed with the first one. Paul Branier, sorry for not being able to pronounce. Go ahead, Paul.
Unleashing the power of multi-cloud MariaDB database management. Hi there, thanks so much for joining. My name is Paul Brunier. I'm the Director of Sales Engineering here at Virtuoso, and a thank you to the MariaDB conference organisers for inviting us to talk with you today. I'm here to talk about MariaDB deployments, but around cloud environments. There's a very brief agenda here. We're going to talk through a little bit about what this means and why people are moving into the cloud. Multi-cloud cloud adoption is here, who's doing it and why. I'm going to talk very specifically about a customer use case I'm personally been working with, this particular client, a large client in the finance sector, that have used the Virtuoso platform to help them with their MariaDB deployments. And I'll talk a bit about what they have done and we've developed with them code to enable a particular multi-cloud deployment of this. Now, I'll get into the details about what all that means shortly, but I'm going to talk about what we've done, and then I'm going to give you a demo of our platform, and then we'll end up with a Q&A session. Hopefully, we've got enough time. First of all, databases do actually keep moving to the cloud. Anybody that's worked with database systems for a while will probably have started with deployments on-prem onto local devices, servers, and so on and so forth. We can see from the chart here that Gartner is actually charting the rise of revenue, but it's a rise really of databases being deployed into cloud environments. Now, we could say, well, what do you mean by cloud environment? And we'll get on to a little bit about that. Overall, the takeouts from this is that cloud services, sorry, database services are growing, but specifically database deployments on cloud are growing a little bit higher than database deployments on premise as well. The good news for all of us is that database usage and therefore deployment is growing overall, so that's that's a good thing for us. But databases in the cloud, there's a number of reasons. I'll just touch on very briefly some of these here. One is about innovation. Databases, MariaDB, new wave of services, we tend to associate those with sort of cloud operations and cloud services, cloud applications and so on. Innovation is one of the drivers for organizations looking to place database services into cloud platforms and cloud environments. Security is another factor. It's a big driver. But basically every organization, but specifically a number of organizations are coupling, if you will, pairing security and enhanced security, a new wave of security with cloud-based services as well. That's another driver. Cost efficiency. This one's an interesting one. Anybody that's been using cloud for a while probably thinks, actually, cloud isn't always cheaper, and it's not. Is it more cost effective? It can be, and the true answer to that question is it depends. It depends upon so many factors. We're not going into that today, but the use of cloud can deliver cost efficiencies, time savings, operational savings, and so on. Scalability tends to be one of the cornerstones of operating with cloud services. It can be viewed as limitless, not really, but it's that whole premise that there's resource on tap, which helps any environment when it needs to scale and flex in different directions. So scalability is key. Reduced lock-in from having one single platform environment on premise. I mean, again, I think this is a moot point, but when we get into a discussion about multi-cloud operations, this is where we're not necessarily tied into one specific cloud provider. We'll talk about that as we go on. And then people's fears about migrations. These days, I suggest no. It's a mature way that we look at the market now, and there's lots of migration tools and lots of knowledge about migrations, migrating virtual instances, database, content, etc., from one location to another location. So it's much less of a concern now. And if anything, it's an enabler to help people, because it's maturing, to help people move to consume database services from cloud operations. Now, the multi-cloud adoption, a chart here from Flexera. You may be familiar with their State of the Cloud reports. They publish them every year, have done for many, many years. They're basically saying that in terms of cloud adoption, 87% of organizations that they canvass using cloud, using actually multiple clouds. I've read a statistic recently that talks about enterprises are using on average 3.8 clouds. Now, are those clouds, hyperscalers, public clouds, are they private clouds? Well, it's a mixture. And again, Flexera have extrapolated these figures out, say 72% of all multi-cloud adoptions using a hybrid model. That is private and public. It could be a mixture of on-premise clouds, it could be a mixture of public clouds from hyperscalers or taken from any cloud service provider. The point is, multi-cloud is here, it's all around us, and we are working within these environments. There's many reasons why organizations are using such multi-cloud architectures, and there's a few details here. I'm not going to go through all of these, but it comes down to lots of business drivers. We're using multiple clouds because we have applications siloed in different clouds, or apps have been developed for one cloud, not another cloud, or they're suited to one cloud. Many, many reasons. We're not going into those. And yourselves, you'll have reasons for this, or if you're a service provider, databases, and your clients will have many, many reasons for all of these as well. There's pros and cons to doing all of this. We look to embrace multiple clouds because we get different benefits from them, surely. Well, this is true. We're not going into the differences. What's the difference between AWS, database services, and Google and so on? We don't have to be as simple as that. Fundamentally, for me, it gives organizations and developers, DPAs, whatever, it gives more choice. You've got more leverage there. You can reduce risk for sure. But any time that you introduce multiple of anything, you can introduce complexity. So we've got to be mindful of this as well. You know, management, governance, various points at the bottom of the screen, data dispersion. If you have data elements, data sets, different physical cloud locations, physical cloud, how do you best manage those? We can talk about that as we go on. You know, we have some ideas. This is a virtuoso, have some options and solutions for this. So why am I here, and what do virtuoso do that could potentially help or be of interest to yourselves? We have a software platform, we call it Virtuoso Application Platform, and the easiest way to describe it is as a PaaS solution to enable you to build your own cloud services with. So private organizations take our software and they build their own cloud with it, and it can be private, it can be public. A lot of our customers are service providers, and they take our VAP software, Virtuoso Application Platform, and they use that to build their own application-focused cloud services. Now, VAP can run pretty much anywhere, bare metal, infrastructure as a service. It can run on those cloud platforms you can see at the bottom, OpenStack, AWS, VMware, and so on. It can run on all of these. What it gives you is an application focus, a DevOps, if you will, enables environment to help you manage application services. Now, we're here to talk about, this is MariaDB conference, we're talking about databases. Databases for us is a subset of that overall, if you will, application enablement or anything as a service capability that we have. So we'll talk about that. We have a number of, we can use the word pre-configured database, but these are database environments supported specifically by Virtuoso in our application platform cloud. MariaDB is there, there's a few others out there as well. And when I say that we pre-configured and we support them, we have templates. We've also basically have various configuration elements, if you're pre-baked, to make it easier for you to deploy MariaDB environments. Now, anybody, and I'm assuming that most people here, very much used to setting up MariaDB databases, you know, clusters manually. There's a number of steps you go through. And we've got a picture of this, you know, poor old DBA here, you know, head in hands because they've got to go through steps. It's a little bit complex. What we do, very briefly, is we just simplify this for you. We make it easier for you to manage, deploy and manage MariaDB databases. And when I say that, we have elements templatized, so you can literally 2 clicks deploy a DB cluster. But we've also got smart signal software that enables these to automatically scale horizontally, vertically as well. We can have all these clustered. We're going to get onto some of the topologies later on. But the point I'm trying to get across is that we have a tools inbuilt that enable easier management. So we do a lot of the heavy lifting, and you can do more of your database design, whatever it is that you have to do as well. So I want to bring this into, if you like, the real world by talking about a specific use case. This is a national bank. It's not in Finland. It's not in Europe, in fact, but it's a customer I deal with in Thailand. It's a major national bank. I work with this bank for the best part of 2 years now. They came up with a requirement that they were looking to develop their own database as a service to run as a private cloud for their internal customers. So the database management systems they were using, and they wanted to focus on MariaDB, also some PostgreSQL and Redis in there as well. But they specifically wanted to be able to deploy these to operate across 3 separate data center locations. They wanted clustered, and they wanted multi-region operations. So we were doing clustered databases, but pretty much, you know, primary, secondary, as in topology deployments. So we had to get into development phase with this to validate or ensure that we could validate that we could meet the bank's requirements. This is a little bit of a busy diagram from the customer. Talking about their 3 different data center locations. And these are all in 3 different cities. Well, one in city, which is a major city capital, and one elsewhere. But they had basically a primary data center. This is a block in green, BBT. Let's not go into details, doesn't matter. A secondary data center, and they wanted active loads between the data centers, and then a failover DR data center. So they managed all the networks, high-speed backbone between them, and they wanted us to develop or to deploy database as a service cloud for MariaDB that operated primary, failover, but they could operate from any of these three centers. And so what they were asking for was a multi-region clustered database solution for MariaDB as well as PostgreSQL and Redis. Now, we started this particular initiative in June last year. The first go live was September, second go live was November, and they've been enhancing the system through into this year and adding more and more smarts into it. Excuse me. The software development was needed, so it was access to devs and DBAs from our side and also dev DBAs from their side as well. And actually tying these two together when there was roughly a 5-hour time difference between our development centres and where they were was interesting, and also language as well. Then networks. Now this proved to be a real sort of a key area where I had to put a lot of focus on the customer did as well. So we found, even though the networks were supposed to be identical between these three data center locations, they had very different performance characteristics, different latency, delivery times. Oh, that caused us some interesting. So much so, we'd introduced several weeks delays into the project where the customer had to get in, special network specialists, to perform third-party assessment on some of their network operations. And sure enough, they uncovered some problems and they rectified them. It all took time. What we did is we needed to build our own dev test platform, which mirrored what the customer was deploying as well. So we had to do investment in that to mirror as closely as we could what the customer was doing, but that's fine. And they also said they wanted to do very thorough and rigorous performance testing with all of these, and they wanted us to prove that a database operating in one of their data centers was actually equal to operating anywhere. So they wanted us to validate this. They wanted to go through a whole raft of performance tests, which is fine. So we settled and we recommended using Sysbench. Probably most people here have used this, just a sort of screen grab there. But what we found, and probably no surprise, a multi-region deployment significant or can impact performance, so it's going to have latency. But where you've got primary, where you've got workloads being initiated on different regions, and obviously updates are travelling across to other areas, of the organisation, the whole topology there, it's going to give interesting performance results. But we use Sysbench to actually engineer in, if you will, checks and balances from our side to make sure that this was actually operationally working and that kind of thing. The customer wanted to read this. They wanted a repeatable method to actually test and validate it themselves as they went forward and deploy more applications into it. So we ended up actually teaching the customer about how to use Sysbench. So in terms of different topologies, so these are the different topologies we support, and they also asked us to do the multi-region deployment, but they wanted a primary approach to this as well. So standard MariaDB topologies, or primary, secondary, Galera, that's what we support, and this is part and parcel of our platform, where you can just choose drop-down menu, I want to deploy MariaDB with this topology, and it will go and automatically configure all the load balances and so on. So that is part of what I was saying about we do the heavy lifting for you for deployment of these. Now, they also wanted multi-region deployment, multi-region cluster, and this is what we actually built for them, where, excuse me, and there's a little cutout of a dialog box here where the customer can select multiple regions to deploy the particular elements in primary, and secondary deployment. So we did this as 3 ways, that's what the customer asked for. So Maria multi-region for us is basically clustering the database with primary, secondary, but across different physical locations. So we've got region A, region B, region C, these different data centers. And so we ended up with deploying multiple of these actually. We started off by deploying this is a private cloud for their internal customers, but then they actually wanted this repeating a subsequent phase to develop their own public cloud. So using MariaDB, again, same construct, so primary, secondary, basically resiliency, fault tolerance built in to be able to then sell that service. And I think they brought their first paying customer on in Q2 this year. So okay, that was very interesting. But in terms of this as a diagram, we talk about regions here, but these are different clouds. And when we have deployed VAP, we refer to VAP being the cloud. VAP can sit on any platform pretty much as I explained earlier. This so happens that it's on-prem on physical platforms that the customer provided, but we can deploy this on customers' OpenStack, VMware, AWS. So we can have AWS here and GCP there and on-premise there and VMware and OpenStack. And to us, they're just multiple regions. They're part of a multi-cloud strategy where we actually put an abstraction there of, if you will, software that helps you deploy your database architecture across all of these clouds. So this is where the multi-cloud element comes in. Very interesting one, I believe it is. Best practices, what do we learn? Never make assumptions about database requirements. Obviously, really, the customer, by the way, was looking at AWS as an option. And they realized they would have to learn a completely different way of dealing with databases, which they didn't feel comfortable with that at all. The key to document everything when you learn something, hear something, get some requirements from the customer, document it, echo it back to them. I know this is kind of really sort of basic stuff, but this is what kind of works, and we had to work this way. Network operations, this is probably the key point. We had to understand how the network operated and what performance was expected, what we could get with it. We had to do tests of their network and make sure that it was satisfied. It satisfied us and our DBAs that yes, their network is consistent, it's reliable, it's performant, and so on and so forth. Customer expectations, I put there, can be significantly impacted by the network, and yes, it can. So performance testing, as I said earlier, agree upfront what sort you're going to use, make sure you know how to use it, make sure the customer knows how to use it as well. So Sysbench tends to be the most widely accepted tool there. And we're going to make sure as well, it sounds so obvious, but when the customer's got multiple data center locations, different data centers, make sure that the architectures they're deploying on are the same. Or if not, the customer understands that there's a complete difference in overall performance, NVMe's to SSD, spinning disk, what's the network topology in the local data center, are we talking 1025, 40 gig, whatever, so on and so forth. Now, probably we're all technical people in the room, so I'm sure we're okay with that. But we had to go through that process as well. The customer also insisted on, whenever we got the code ready, because we released it in various sprints, we do 3-week sprints to develop it and deploy. And they wanted to go into POC environments. So we built a POC environment and made sure that they were comfortable and happy with that and so on. So POC acceptance criteria document, absolutely key. But use that as a working document to go through checks and balances with the customer. Really, really important. So overall, what we have is a streamlined DBAS deployment and management platform with our virtualized application platform. Now, it's a you can call it a general application platform, turnkey PaaS solution, but we've got some smarts in there relative to database deployments, as well as some other applications, WordPress, Magento, and so on, which I don't feature here. But our platform is all about helping you run your database environments, helping you with fast and easy deployment, fast and easy configuration, and reconfiguration as well. So inbuilt high availability, make sure the performance with resource usage as and when you need it. So if you're dynamic resource balancing with, we have this elastic engine under the covers and so on, that can help optimize costs and so on. The point about that is that this is an enabler to help you manage your MariaDB environment deployments that bit easier, hopefully, you agree. So right now, I'm going to go to a demo. I'll just talk about database as a service, database platform as a service, because our platform software can be deployed in either scenario. If you want to take our software and install it yourself in your data center, that's fine. And then use that hosted, on your own infrastructure and services, that's absolutely fine. If you wanted to actually take this as a service, that's absolutely fine as well, because a number of our service provider organizations, they offer services where you can just take a database service from them. So from us, either model is fine. We simply provide the software, however you choose to use it, either use it directly yourself in your data center or take service from a service provider, absolutely fine. It's the same software, you get the same benefits from it. Okay, so I'm going to go into a demo now. I've talked about this long enough. Hopefully that actually gives you a good insight into what we are and what we've been doing. Right, so I'm just at the logon screen now for the demo of this particular environment. So we'll log on into the Virtuoso application platform. And when you see the screen, it comes up and it gives me a list of the active applications that I have live at the moment in time. As you can see, I've just got one here, which is a MariaDB cluster, and that's comprised of a number of different components. We're going to come back and have a look at that in a moment. That's just the version that I've already had created. But I'm going to show you a little bit around this environment with a view to then creating our own MariaDB cluster. Then I'm going to actually show you how to create one across multiple clouds as well. So really simple information, a few menu items at the top, new environment, we can import applications code, we can have a look at the marketplace. There's some settings over here where we can set up things like two-factor authentication, change password, establish access tokens, SSH keys, and so on. We've got an interesting collaboration feature here as well. Such that when one person, for example, sets up a particular database environment, they can share, collaborate with others, with their colleagues and so on, so you can share administration duties around the environment as well. Similarly, other people can share their application stacks and their database services that they've created with you, for you to help administer as well. So there's a number of activities there we can do in sort of the initial settings. We've got a whole heap of help activities all built into this particular platform. So you can contact support, have a look at the documentation, have a look at how to set up and use APIs, CLIs, you've got videos, tutorials, so on and so forth. So there's a lot of help and information available at your fingertips with this particular platform. So what I'm going to do is just go through the mechanics of showing you how to create a new MariaDB environment. So we click on New Environment, and then we get this environment, if you will, topology wizard set up. Now, you can see along the top, we've got various types of environment. We could go with Java, PHP, Ruby, .NET, etc., etc. By default, it'll come up with, for example, PHP with an Apache server. So this diagram on the left-hand side, this is where you actually build an application stack. So you can build application servers, you can have load balancers and so on from sending a database, but we're going to deselect that and we're just going to focus on MariaDB. So this is a framework, allows us to build an application stack with many elements in it, but for this demo right now, we're going to focus on MariaDB. So I'm going to select MariaDB, and if you just press that chevron there, you can see we've got lots of different versions that we manage. So Virtuoso managing to create these within the platform, and then as and when new versions become available, we test validate, we add them in, that all happens in the background automatically. Let's go with the latest version, that's fine. And the way this works is, right, I'm selecting one particular node that is going to be my MariaDB database. Now, at the top of this, you can see that we allocate resources, basically memory and CPU, in terms of what we call a cloudlet. So a cloudlet is a small piece of RAM, basically 128 meg, and it's 400 gigahertz of CPU, so it's a slice of a CPU. MariaDB needs a little bit more than that to get going, so by default we set MariaDB as needing 4 cloudlets. Now, over here, this box, you can see this is a scaling limit. You can hover over all these question marks, by the way, to give you some clues. Scaling limit indicates how many cloudlets can the system automatically scale up to. So lower and higher limits, which basically gives a range of memory and CPU available to that individual node. And you can set this for every single node within the actual environment you're setting up. Now, simple thing is, if I grab that with my mouse, grab that slider button and move it one way, I can increase the number of cloudlets, I can decrease the number of cloudlets, and so on. So you can either type the numbers in those boxes, use the slider controls, whatever. But in doing that, I'm actually indicating an upper and a lower limit in terms of the amount of system resource I'm going to allocate to this particular environment. So this is set up initially with a single MariaDB node. I want more than that. I want at least 2. Okay, I want to cluster them, so I'm going to hit that button, clustering on. And now automatically the system has already added a proxy SQL. So this is a proxy to enable, but if you like, that workload balancing between those two database engines, as it were. Now, I can implement this in a couple of different ways. Primary, secondary, primary, primary. And if I just hover over those, you get a little schematic there, just showing you what the actual, if you like, architectural setup is. Primary, secondary, and also Galera. If I go with Galera, I'm going to need 3 nodes because of the way that Galera works. But again, if you're familiar with that, all of those different technique topologies are available. Let's go with primary, primary. I'm just going to knock that down to 2. Primary, primary. That is good. So a few more parameters there. We're not going to go into those. One of the interesting areas is over here on the right-hand side. When we talked about multi-cloud earlier, this is where we can select where this MariaDB environment will be created. Now, this is a demo system, and here this is a multi-cloud environment or demo environment we have. So we just got clouds in here. Now, I said earlier during the presentation, we can deploy bare metal, IaaS platforms, essentially IaaS here. We can deploy VMware, we can deploy to many, many different areas. So I'm just going to choose the first one, Volta. But the point is that you can add whatever locations, whatever clouds, whatever regions you want in terms of the VAP setup. So you might only have one particular, hyperscaler. You might have others of VMware, others on-premise, KVM, opens absolutely fine. You can do all of that, and that is what VAP will actually work with. It will work with whatever cloud platforms you tell it you want it to work with. So we're just going to keep with Vultr now, just by way of an example. And down here, I am just going to set the environment name. So I am going to call this one MariaDB, whoops, I can't spell, MariaDB cluster demo, cluster demo, there we go. And I'm going to hit create. There's a bit more information there about resources and about costings and so on. We're going to just ignore that for the time being because that is can be subject to a complete separate, quite a long discussion. I'm going to hit create. And so what we've actually done is defined an environment with MariaDB cluster running primary. The system automatically included proxy SQL, so it's going to take just a little bit of time creating that. Bottom left, you can see on my screen, it says 5 active tasks. If I click on that and open that window, it'll just give me running commentary about all the tasks that are going on right now. So, a number of activities, so you can just watch what it's doing in the background, or not, as the case may be. I'll just collapse that down. Now, in terms of his one I created earlier, the first one, MariaDB cluster 01, this is basically one I created earlier, so it's already established because it'll take a few minutes for that MariaDB environment to be established. Here, I'm just opening this up, and you can see the individual components within this particular cluster. We've got our MariaDB cluster. This is configured in the primary secondary topology. And then we've got our 2 proxy nodes as well that's actually managing the workload between those 2 MariaDB nodes as well. Now, as I'm moving my cursor onto those, you can see the number of icons that become available here. If I click on the first one, for example, open in browser, it automatically just loads phpMyAdmin. Now, when you create an environment, you get sent emails for all of the login credentials. So I'm not going to go down that route. I'm just going to show you the mechanics of how we actually interact with this. So that is the first one. Now, interestingly, we've got this feature called add-ons here. And once your database is established, I can click on add-ons and I can add additional capabilities, additional services into my database environment if I so choose. Now, here, I'm just going to move my window meat out of the way. We can add in, for example, or we can run some diagnostics. We can get into database cluster recovery, so we can add these things in. So, for example, database backup restore add-on is a common one that people use. I click on install, and this is a database backup restoration add-on that I can add in. So it's a simple scheduler. Okay. What am I going to add in, or in terms of the schedule? I'm going to do hourly, daily, whatever. Backup storage, so when you specify backup storage, I don't have any storage here. So you identify your backup storage, question marks there, so you can actually hover over that and get information, how many backups, my database user, it's auto-populated it with my own credentials and so on, and this is environment name, because I specified the add-on relative to the database that was already created. So I could go ahead, okay, I only specify backup storage there, so I don't have that available at the moment. But then I'll just click install, and then that is an add-on service to my database environment. The point of me showing you this is that it's very easy to set up an environment with these tools, and it helps you manage it a bit better, more efficiently, and so on. Now, you might have other ways that you want to manage it, and that's absolutely fine. These are there, optional. You can use them if you wish. Okay, so a few other options, but that is what we call add-ons. So these are the elements that we can, if you will, build upon your management capabilities within this VAP suite. We can get down, we can restart the nodes for whatever reason, it might have stopped, want to restart it. We get into the config information details. So this opens up basically a list of, if you will, directories, files relative to that specific node. So we can have a look at some of these, custom CNF config files and so on, and have a look at some of these. Okay, so we're getting a lot of access to tailor, tweak, interact with, and so on. We can have a look at a load of log files, fine. We can also have a look at stats. Now, stats is an interesting one. I'll go a little bit larger. So stats will give us metrics about the resource consumption. I mean, you can see all of these different windows here. You can see that something has been created. My environment's been created by the message top right. That's great. CPU usage, RAM, disk, and network. So it gives us immediate information about what resources I'm consuming, and it also will store these over a period of time. Now, that environment has only recently been created, so I'm not going to go back, days and weeks, but you can, and it will store those metrics for you. So you've got access to metrics pretty easily here as well. Okay. Now, a couple of other areas. This is my existing, I'm just going to minimize that. That's my new cluster because I'm halfway through talking. I can access Web SSH. I can go into that particular option, and it'll just drop me down into that individual node, and I'll get a command line prompt. So I've not even created a database there, but all of the if you like, framework is ready for me to start interacting with, building out and interacting with that database and so on. Okay, what else have we got? We can redeploy the container. So that is a system container, because we basically encapsulate everything in what we call system containers, and we can get into some more specific information, direct SSH, reset password info. We can even delete as well. Now, that just gives you a bit of an idea about how we can interact with a specific cluster. Now, I'm going to have a look at the one that we created, because it's actually very, very similar to this, but this is the one that you saw me create. This just shows that it's actually there, and this is the one that's in primary. We've got the message top right. If there's any problems with the deployment, you'll also get messages top right as well. So I'm just going to hit that X just to make that go away. And here, again, we can actually have a look at this. Now, you can go in and you can change any of these things, any of these settings as well. If I go up to the top level, which is the stack MariaDB cluster demo, and I hit on this settings icon, it opens up this submenu here, and I can go in and define settings, change points, and so on, all relating to that MariaDB environment. Set up custom SSLs, SSH access is another route into SSH into that particular node. We can set up endpoints, and again, limited time, I don't have time to go through all of these. One of the areas I did want to talk about was about horizontal scaling. So I've talked about the cloudlets when we were building a new environment, and about how the system can flex between the upper and the lower limits in terms of cloudlets, the RAM and CPU and so on. With horizontal scaling, we can actually take that to another level as well. So with this, we can define triggers upon which the system will scale horizontally. If you think about sort of CPU, RAM, that's more of a vertical kind of a measure there, and here we're actually doing horizontal scaling. I just need to, from this menu, I need to select, so is it SQL databases or proxy I'm going to refer to. To enable it, I have to click these boxes, add nodes, remove nodes, and right now by default CPU is actually set. So what this is basically saying is, when the CPU loading my SQL databases reaches more than 80%, you can change that. For a time period, for at least 5 minutes, you can change that. Scale out to 3 nodes. If I've got 2 nodes, it will add another node. And you can change that. You can keep on going. How many nodes do you want? 3, 4, 5, doesn't matter. You can just keep on scaling them out. Now, obviously, databases in primary, secondary, we're going to end up with more secondaries and so on. So obviously, you need to pay attention to how the topology will be actually used and operated. But this is a principle which applies to anything, to the proxy SQL elements, if you had some, Apache servers in there, the servers, etc., etc. The point about this is that you can consider this a set and forget type mechanism where you can set the trigger and it will automatically add and spin up another node. And it's all about easing the management burden of yourself and having the system become or operate quite autonomously. Now, you don't have to do this, and this might be applicable for some particular workflows and not others, but this capability is inbuilt. So as well as being able to add nodes, when, for example, CPU reaches a certain level, or we could do memory or network disk I/O, we also remove nodes as well. So when the resource consumption goes down to a certain level, we don't need those extra nodes. They're consuming, some resource. Let's just remove them. Okay. Obviously, whatever the app, the database is got to be able to cope with that. But that is a mechanism which is really interesting. So we have both vertical scaling and horizontal scaling as a core part of this engine, if you will, of this platform that we can run the MariaDB environment on. So I'm just going to minimize that. There's a whole heap of other areas. We talked about migrations and exports, so we can actually migrate database, in this instance MariaDB. We're going to migrate it from and to somewhere else. Okay, you can do that depending on whatever regions are there. We can export and so on. So I've not exported environments, so I can export environments to be able to move that. It's a separate process to go through. Not got time to go through all of these yet because I wanted to come back to the way that we can help you provision databases, but specifically across multiple clouds. Now this one, I've deployed in Vultr, MariaDB cluster, and it's all been set up. I'm going to have a look in the marketplace now. This is a different way that we offer part of this solution where we can give you the tools to be able to provision quite a complex environment within just a couple of mouse clicks, literally. I just clicked on applications there. There's a whole heap of applications. So we curate all of these. I'm just scrolling through a couple of pages now, and we can go to clusters. This is where we've got MariaDB multi-region cluster, and this is a multi-region Galera cluster. I'm just going to stick with multi-region cluster for now. And we hit that install button, and it comes up with this dialog. Now, it's asked me just a couple of questions, and then it'll go off and do its work. What regions am I going to deploy into? So, do you remember I talked about clouds and regions? Now in here, I've got a number of different ones. I've already selected Vultr, AWS, GCP. Obviously they're in the list. We've got DIO, we've got Azure as well. But let's just stick with AWS and GCP just because they're there. Great. So them are 3, database version. Let's stick with the version 11, and then environment. I'm going to give it a name. So MariaDB. Excuse me. This is going to be MariaDB cluster. Demo MR for multi-region, okay, and then install. Oh, okay, so I just chose that option there. It's a MariaDB database that's going to be installed as a cluster across multiple regions. All right, so I've got an error message at the top of the screen saying it doesn't have free hardware in a particular region. That's okay. It will deploy however much it can, actually, depending on availability of resource. Now, I'll just minimize that and close the marketplace, and you'll actually see a lot of things being installed now. Those 2 elements in the middle which are highlighted, they're the ones that I've already created. Everything else is getting installed separately. So we've got, for example, at the top, database multi-region topology is kind of grayed out at the minute because it's still installing. That's on Vultr. And then the next one is, what's this? AWS, because I'm looking at the tags. So that indicates where we're actually deploying this. So obviously the, what was the other one? GCP, wasn't enough system resource there to install it. But you can hopefully see that this method allows us to install MariaDB database across multiple clouds and have that cluster spanning those clouds. When these are all complete, and this will take probably 15-20 minutes, so we don't have time during this demo to wait for it to complete. But when it does finish, we can interact with it in exactly the same way that we're interacting with our other MariaDB environments. So we can go and set a horizontal scaling, sort out the access, change collaboration, change owner, and so on and so forth. We can also get into all of those add-ins. Remember, I talked about the add-ins with the backup, restore add-on, the cluster recovery, running diagnostics, so on and so forth. So basically, what I'm showing you here is an environment we have, a virtualized application platform. It's just actually deploying a lot more now. That gives you the ability to deploy and manage MariaDB environments, we think, a lot easier than having to do everything by hand, having to code everything and do everything methodically step by step. So this is a set of tools which we believe make it a lot easier, make your life easier to be able to go and deploy all of these. Actually, this went through a lot quicker than I was expecting, so that is great. So now we've got, I'm just going to minimize these so we can actually see on this screen now. So what we've got is primary, in Vultr and in AWS, and then the proxy SQL in Vultr and AWS as well. So we've got the proxy SQL there. So that's actually been a successful deployment across two, so it's clustering across two specific clouds, Vultr, AWS, which is quite something. But hopefully that gives you an idea about the capability of this platform in supporting the MariaDB deployments. Now with that, I'm going to drop back into this particular slide here, because that is the end of the demo, and hopefully that has been of interest to you and will spark some, thought and debate and so on. If you want to know more, you can scan this QR code. You can contact us at info@virtuoso.com, or you can, contact me directly. It's not a problem. Paul Brunier, paul.brunier@virtuoso.com. And I want to thank you very much for your attention and your time with this, and I hope to hear from you soon. And I think hopefully we've got enough time. Yes, I can. Yes, I can. Thank you. Good morning, all. Okay. Yeah, I can hear you. Can you hear me? Perfect. Thank you.
From a usability perspective and a documentation, should we say, change configuration management perspective, how does one manage this complexity? You were clicking around in menus, and somewhere all of those settings need to be documented and followed up and looked if things change. So how do you go about so that there is a, shall we say, reproducibility in this? And you're talking about really complex settings with a testing environment and a production environment. So do you have any comment on that?
Yeah, and to be honest, it really merits a discussion in its own right. But very briefly, I showed you what we call is the end user dashboard. We also have an admin dashboard as well. And again, that will take time to go through, but that is when we do all of the settings. We identify and, if you will, define, for example, all the different cloud environments we're going to be working with. If we just take this back a moment in terms of the installation, the VAP platform itself can be installed anywhere. And we require either 4 servers or 4 virtual machines just to install it on. And those virtual instances can be an OpenStack, VMware, all those platforms I talked about. So the actual installation and so on is very straightforward. Under the hood, there's a lot of microservices. It's been built using Java originally. So it actually comprises an Elastic engine underneath it. And it basically offers that usability front end. In terms of the documentation and, as you described, it can be considered to manage quite a complex environment. We have full suites of documentation, full suites of training. We have our own training portal with a number of different levels, tiers, if you will, of training accreditations that some clients choose to take. The whole idea with the way the platform has been built is that it's designed to be intuitive, that you can actually learn as you go through and figure it out. We've got a whole PS team behind us that can help people as well, and the training department. So we are trying to build a platform which is accessible and it's easy to get started with. It does actually hide quite a bit of complexity behind the scenes, as it were, but it just gives you the tools to hopefully, you've seen a quick snapshot to allow you to manage it in a fairly simple way. I don't know if that answers the question.
I think it does. I was also thinking not about the documentation of your system, but also the documentation of the settings. So this is the configuration which I have. But I will hand over the Andrew had a question here.
Yes, I did. Yep, so I'm Andrew Hutchings from the MariaDB Foundation. First of all, love the multi-vendor cloud setup. I've been kind of banging that drum for a decade now that you don't want to put your eggs in one basket for that kind of thing. So first of all, that's fantastic. We are a room of very smart kind of MariaDB developers here, and we would like to know, since we're planning the future of MariaDB, what kind of things would you like to see? What will make it easier for you to be able to do this with MariaDB?
Well, make it easier from a MariaDB perspective.
Yeah.
I think that one of them is telemetry information that comes back into the actual framework around which MariaDB is being deployed. I think using, in my interactions with clients, when they're looking to deploy this, the key areas about network management and then performance management, they're the two areas I end up talking with clients about. They want to know how they can actually monitor and manage networks specifically. And especially when you get into multi-site or multi-region deployments. And secondly, as per the use case with the POC, performance testing, if there's more information, more accessible information just around the performance characteristics and how you can actually validate repeatable scenarios. Because we had to build elements using a Sysbench tool, but it was pretty much an open book with the client at this case. So when we're talking, myself and the team around me, when we talk with clients about database deployments, it tends to be a bit of an open discussion, and I think a bit more, if you will, clarity and direction, things that we can very specifically use, tools perhaps that can help, not for us, but deliver to clients repeatable scenarios, like testing scenarios, performance scenarios, load balancing, recovery kind of scenarios as well. I think that all helps because we're having to craft those ourselves. And to be honest, it's more of a bespoke operation depending on individual clients. So I think kind of standardizing some of those, I think that would help just off the top of my head, Andrew. I hope that helps.
Yeah. That does, and in fact the foundation is developing a project called Scary, which I think will fulfill some of those needs. So
fantastic.
That validates what we're doing.
Great, thank you.
We have time for a couple.
You showed off the horizontal auto scaling in your UI for example, triggering at like an 80% CPU threshold. I'm kind of curious if that works well in practice, because when you're scaling up and adding new nodes, doesn't that new node then have to be synced, which then kind of increases the load? I'm just wondering if, in practice, if it works well or if it's something that people tend to turn off.
First of all, you don't have to implement the auto scaling. It's completely user configurable. Secondly, the way that we actually deploy a VAP platform is we actually gather together the resources from, we call it a number of VAP nodes. And again, we use the word node interchangeably. Think about this simple example. We're installing VAP across 4 servers. Those servers are going to have, perhaps dual CPU, lots of cores, there might be, 512 gig, terabyte of RAM between, obviously we can start a lot smaller than that. The auto scaling will use whatever resources available across the whole pool. We aggregate all the resources together across all of the available either physical or virtual servers the VAP is deployed on. So what we're doing with the auto triggering is when the usage of a particular system, application, database, whatever, hits that threshold, we're just going to increase another node. The node, in that context, it's another virtual instance of either a virtual machine, a VPS, a database, and so on. So it will simply consume more resource. 4 cloudlets, if you remember, sort of 512 meg, and I think 1.6 gigahertz of CPU from the available pool. So in practice, it actually works really, really well. Apologies, I couldn't actually get a demo system to kind of load up to actually show you it automatically generating more nodes and then scaling them back. But we can certainly do that. Obviously it needs a bit of prep just to actually set the environment up. But yeah, it works very well in practice, and we're very happy to show you that as well.
Great, thank you. One more question.
Hello, I'm Marcus. I just was interested in the multi-primary one. I saw in your diagram you had different acronyms, and then the disaster recovery side was read-only one. That was correct, I assume. And what I'm interested in is what kind of multi-primary are you writing to both nodes, and do those datasets intersect? Or is it more of the partitioning per cluster, and the disaster recovery is mostly read-only?
Yeah, Marcus, thanks for the question. I think you're referring to the different topologies, primary, secondary, primary, and then we call it Galera. And that's when you have at least 3 primaries. And what we do is a synchronous write operation to all of those 3 primaries, or whatever many primaries you've got at the back end. It is built upon a Gluster file system underneath that as well. But it's a synchronous write operation to keep all those 3 or more nodes in sync with each other. Obviously, doing multiple writes, you've got a little bit more latency at the back end for that. But yes, it's hopefully that answers the question, Marcus, if I understand.
If we have time, not the Galera, but the 2-node primary. I was very interested in that one.
Oh, actually, yeah, the 2-node primary. So we use 2 proxies, and they're writing basically synchronous. So one proxy will write synchronous to both primaries, depending on where that write I/O comes in. So it's very much a synchronous I/O operation. Primary, they've got to be in sync, absolutely in sync, before we send acknowledgement back. Primary, secondary is, obviously that doesn't have to be kept in sync at that point. But yeah, it's a synchronous write operation from the proxies down.
And you can do parallel writes on multiple proxies, I believe.
Yes, correct, yes.
Yeah, thank you very much.
Thank you, Marcus.
And thank you, Paul. Really good presentation and interesting Q&A session. Thank you. And we will now go for a coffee break. Paul, I hope you will have coffee somewhere close to you as well. And the same goes for the virtual audience. Thank you.
I will indeed. Thank you very much, everybody. Appreciate your time. Thank you.
Yeah, it's basically.
Okay, let's start then. My name this is a talk about MariaDB release model, and okay. My name is Riga Lubchik, and yeah, I'll be talking about mostly about the history about MySQL at MariaDB release mode, but also last third of the talk will be just comparison of what we have now and directly before that. Yeah, so I specifically start with the history and dedicate most of time to it because I think it's very important to understand how the current release model came to be. That was all on the video. And so that we wouldn't repeat old mistakes by doing something that we already tried and we know it doesn't work. So I'll start from, well, early enough, not the very, very beginning, but early enough. So from MySQL 3.23 and up to 5.1. That's years 1999 and up to 2010. So at the beginning, MySQL used to have alpha, beta, gamma stable cycle, and later, as far as I remember on the marketing requests, gamma and stable was released to RC and GA, but it didn't change anything substantially. The releases were feature-based, that is, we had a certain set of features we wanted to have in this release, and when they were ready, well, then we made the release, and the release was ready when it was ready. In the very early MySQL days, there was even a principle no known bugs, like we didn't release if the release has bugs that we knew about, we fixed them in the release. That was quickly abandoned.
What do you mean quickly? 5 years?
Yeah, and just to make it clear, for this talk I'm going to use the macros rule. All the questions at the end, no interruptions. And the beginning, MySQL heavily relied on community testing. We got lots of good detailed bug reports from community. They were testing alphas and betas, downloading and installing them a lot. The thing is, at the beginning, at least my beginning on MySQL, the user base wasn't very big, and users were like early adopters, those who install new products. They are technically savvy, they are tinkerers, they knew all the settings, command and options, they didn't afraid to try them. Database for them was a product that they installed, and they consciously installed MySQL, and they were spending efforts to make it work good for them. This results in lots of people using alphas. This results in good bug reports, sometimes even in patches. And it caused the alphas, as a result, were very long. You can see how originally long alphas were. But then user base grew, and users who are coming were different kind of users. They just wanted database to work for them. They didn't even care what database it is. They probably were installing something else that was pulling up database and independency. This is not on this slide. This shift was happening. I mean, those early adopters, they didn't go away, but in percentage, there were smaller, fewer and fewer of them. I mean, the ratio of those users. For example, you can see that in the early versions, alphas were the longest stage in the cycle. For 5.1, this is no longer the true. We had longer beta, and alpha was smaller. That's because users were not as willing to install alphas. They were waiting for beta to start actually trying MariaDB. Another obvious outcome of the feature-based releases, they were irregular. We didn't know when we'll release. It'll be ready when it'll be ready. And not users, and particularly commercial customers, were happy of that because they wanted to plan the feature rollout. So then in MySQL 5.5, alphas and betas were renamed into one thing they called milestone. So there was like milestones, and then RC and J. That didn't change anything much. It still was, milestones were a pretty long step. They're still feature-based, except that MySQL relied much more on internal testing at that stage because users, as I said, user base, quality of users, let's say, put it this way, it changed, and we didn't get as many early testing as we used to. So now, fast forward to MariaDB. I'm skipping MariaDB 5 versions because they were proper fork of MySQL, pulling from MySQL and merging with MySQL, so they're not applicable to what we're doing now. So MySQL, after the talk, please. MariaDB 10, MariaDB 10.0, 10.1, it went back to the familiar, old familiar MySQL model. This is the model we knew, this is the model Monty knew, it worked well, so why not to get back to the basics. It was feature-based, it has relatively long alphas, except that we had almost no internal testing, and relied on the user testing again. But this was fine and it worked because at this point in time, MariaDB project was still new, user base was small, relatively small, and it was again those technically savvy early adopters who tested early versions and reported bugs and created good bug reports. But then MariaDB was growing, the user base was growing, and this was shifting for MariaDB as well. That was basically the same history repeating. And people were unhappy with basically absent schedule of releases. They couldn't plan. We wanted MariaDB to be in distributions, and we need to time releases to be ready when distribution is ready. So for that, we need scheduled releases. And then, starting from MariaDB 10.2, we switched to a train model that is time-based releases. Ideally, it means we release at this specific date, plus minus a few days or a week. And if the feature isn't ready by that time, it just moves to the next release. That's 10.2 was the first one where we tried this way. We immediately realized we cannot keep our old quality standards the way we did before. For example, it used to be that we add new features in alphas, we fix most bugs in betas, RC are just few minor bugs, and then we release a GA. And with that time-based model, we immediately realized we cannot keep doing this anymore, so we've redefined what alpha and beta means to be able to maintain this space and do time-based releases. This was in 2017 when we've changed the definitions, put them out in the knowledge base. But 10.3 was already using new definitions. Alpha was, we changed it so that we could add features in beta as well, as long as they don't break anything for existing users and don't remove features. So we can add new features if they don't break compatibility even in beta. That was the change in definition. So this kind of worked, but you can see that the GA date was still sleeping despite our best efforts. It was, and another thing to pay attention to is the 10.6 release. We started working on 10.6 like in summer or spring 2020, and then in spring 2021 we realized that it's almost time to do the GA, and we didn't even have the first alpha, so we released 10.6.0 alpha in April, 10.6.1 beta in May, 10.6.2 RC in June, and yes, 10.6.3 GA in July. That was the 10.6 release schedule, and it was, as you might imagine, like totally fake. There was no stabilization, no much of bug fixing, and so 10.6 was not a good release. And despite doing all that, and despite very fast forward over all bugs and everything, ignoring problems, we still missed the release date, and it wasn't in June, it was in July. So that's how well train model worked. So what we have now, Now we have, starting from 10.7, we've changed how we do releases. We do quarterly innovation releases with new features. Every release is maintained for a year. Then every second year we do LTS releases, which are maintained for 5 years. Their timing is designed to match the Debian release timing so that we could do a next 5-year release before the next Debian release, so that new Debian could have the newest MariaDB possible with the appropriately long maintenance time. Between the two releases, we have so-called preview releases. The point is to give the users an early preview of the features so that users could complain and comment, and we can still fix something in those features before they get pushed into the main release. But also, preview releases serve as a hard feature deadline, and if some feature isn't ready by the time of the preview release, it will not be in the next innovation release. Which means that, which means that basically 6 weeks after the feature is ready and in the preview release, but before it's getting pushed into the actual release. This is the time we use for internal testing, internal QA, and every feature must get a sign-off from the internal testing before it's getting pushed into the main release. And so this is how releases work. On this model, you can see that now we have very stable release schedule. The dates don't flip. You can see like September, December, March, and June, always in the same month for preview releases, and basically always on the same month for RC and GA, except that there's a release which is timed at the end of May, and if it'll slip a few days, it'll be the beginning of June. But it's not slipping further. There will be no July. It'll begin May, June. It could deviate a few days, but it's still. So we have very stable and predictable release schedule now. For the point of completeness, I'll have a couple of slides about MySQL, although I wasn't an Oracle at those days, so this is just an outsider view. I don't really know how it works and what the problems they had. So for MySQL 8.0, they went away from the previous alpha, beta, milestone RCGA model and changed to what they called continuous development model. That is, they had a couple of milestones, then RC, then GA, and they kept this GA for like 5 years maybe, and they kept adding new features into it. They heavily relied on internal testing, which was supposed to make features good enough to be pushed directly into the GA version. I don't have exact data, but rumors were that it didn't work very well, and quality deteriorated, and number of security issues that are visible from public Oracle CPU reports was also pretty high. So it seems like it didn't work very well. And that's why they switched to another model in MySQL 8.1, which is doing quarterly innovation releases. And twice a year, every second year, they do an LTS release with 5 years. And if you think this looks vaguely familiar to something you've seen on earlier slides, you're not wrong. I don't know why, if it's a coincidence or not, that one I don't know. So, do we have a lot of time or do we have a little bit of time? Probably a lot.
Time until 12:05.
And no.
So 35 minutes.
Oh yeah. I speak fast, so I'm almost ready. So now let's compare to most important, that is the two last MariaDB release models, because those are the models that will likely most highly influence whatever MariaDB will be doing in the future. So what we've learned from 5 years on staying on the train model, which is I'll be calling from now on old release model from 10.2 to 10.6. Well, the basic conclusion is that train model and year releases, they just don't mix. The reasons are to a big part psychological, because when somebody needs to implement a feature that takes, I don't know, a month, and the deadline is like 9 months in the future, then yeah, developer can do something, can fix bugs, but doesn't start working on the feature until there's at least like 2 months before the deadline. At that point in time, it'll start working on the features, and I've seen this like every single year for many people, and I've been doing that myself too, I know. And I know I shouldn't have been doing that, but I was. Because that's still, deadline is in the very far indefinite future, and the feature is so small. Yeah, but then when you start working on it, it turns out to be not a 1 month feature, it's like 3 months, 4 months. And yeah, so the deadline comes, and it turns out every single time that we don't have anything ready at all, completely. So we cannot just roll out a completely empty release with 0 features after a year of working on it. So we do the only possible thing we could. We delay the deadline, and then everybody starts frantically working on their features to have them ready, at least passable in some form to have them getting pushed. Then some features are getting pushed, others are still frantically working on. Then we want to release. Then, like one day before the release, more features are getting pushed, which are not even passable, but can be fixed after the release is done, which doesn't happen. There's of course no place in this schema for any testing at all, because, like, you know, we want to release, and 5 hours before the release, something big is getting pushed. And this is because the deadline is verifying the future, and because if you miss a release, if a feature misses a release, it has to wait a year. So the price of missing a release is very high. And surprisingly, the new model, it has fixed all of those problems. I'm saying surprisingly because it was mostly a coincidence, it wasn't the goal of it.
Completely disagree. Just,
yeah. No doubt. Questions after the talk. So,
then you actually, then you should also say that all these things are yours.
With the short 3-month cycles, it's much easier to plan time, particularly because, as I said, we have preview release in the middle. That's only 6 weeks for one development cycle, and you don't postpone a feature if you only have, if the deadline is 6 weeks in the future. It's basically very near, and people don't postpone starting working on feature. Then if the release is missed, if something isn't ready, the price is very small. It'll be in 3 months in the next release. So it's much easier to say no and release something which has less features in it. Also because the expectations are, releases are smaller, so that there are less expectations that there will be a lot of features in a release if the last release was only 3 months in the past and the new one was only 3 months in the future. So releases could be smaller. It's easier for a feature to skip release because the penalty is much smaller. And it's easier to plan time for developers. Also, this guarantee, we have, as I already said, guaranteed 6 weeks of internal testing. We never had that in the model when a feature is getting pushed without testing 1 day before the release. Everything gets obligatory 6 weeks of testing. Well, maybe less, but that depends on the tester's opinion. But every feature needs to be approved by a tester, and every feature gets its proper beating from a tester. So we do a lot more testing now. And many bugs are found during this period and fixed, and they're not getting out to the users. Also, it happened that a feature didn't pass, wasn't signed off because there was just too many bugs in it, which again was not a problem at all. The bugs were fixed and the feature gets pushed in the next 3 months. This is not a problem. Also, so the mix of 1 year and 5 year release was supposed to have a reasonable, keep the number of branches to maintain to a reasonable number and to reduce the merge overhead. I can tell right ahead that it didn't work. Anyway, so the summary of the new model. So the good stuff are we have much more predictable release scheduler. We do a lot more testing. We don't have those crunches before every release when people are frantically working on features, trying to push them in whatever state. And we have I thought we will be doing a lot more features per LTS release, but it didn't happen, and my explanation for this is because earlier in early model we were delaying, if the feature wasn't ready, we were delaying the release until everything gets ready. Now we do not delay anything, and we still get as many features as we used to do before. But we do have significantly less bugs now. So bugs here, so as the footnote says, it's bugs reported by external users, so not our internal testers. For every LTS release, from the day it went GA, within the next 6 months. That's because 10.11 was out only for 6 months, so I wanted to do like more fair comparison. As you can see, 10.11 was the first release where we had actually less, well, the bugs per feature was below 1. We had less bugs than we introduced features. And particularly if you compare with other Debian releases, with 10.5 and 10.3, 10.11 was much better, like almost 4 times better when our first release, with using this criteria number of bugs per added feature. Well, not everything was good in this new model, so 1-year releases aren't used much. Maybe, yeah, so maybe 1 year is too little, maybe they aren't properly advertised, and maybe the model isn't properly explained because, as we've heard on this conference yesterday, people don't quite understand how it works, so maybe this was the reason. We have very little feedback from preview releases, so the goal of getting them out to users to try and get comments, this didn't quite work out. Although still preview releases were very successful from making a hard deadline for features. The other goal of doing early testing with community, that didn't quite work out. Developing some larger features takes longer, and this is, I think, because people start losing focus working on those short 6-week cycles, and it's something we need to fix. And yes, one of the main problems is we have too many branches and doing too many merges before every release. And this is we definitely need to fix. We need to somehow, well, I'm not going to propose solutions on this talk. This was a talk which is introduction for discussion. And so as a summary, new model, it has definitely fixed problems that the old model had. We now have predictable release scheduler, we have measurably high code quality, and the development is much more relaxed without constant stress before every release. But we have lots of branches and mergers, and 1-year releases, they see little use, large features take longer. So this is what we need to fix. So this talk was an introduction to the discussion about how to change the release model. And in my opinion, we should preserve the good stuff of whatever we do now and fix all the bad stuff, but not throw the baby with the water. And now the discussion time starts, and I think it's going to Pavlov.
Well, we have still 20 minutes here.
Yes, so from the moderation side, as I mentioned in the very start of the day, we have a dual sort of way of working here. One is the unconference and the other one is the ServerFest. And the ServerFest in this room is mostly broadcast with a couple of QAs, questions and answers, as you've seen, and the work on how there should be changes towards the release model, for instance, will happen in another place. And that's actually what will happen now. So when we have the Q&A session, it won't be with the, shall we say, internal people. Monty has lots of opinions and lots of insights. That one will take place in the Pavlov part. So the input here is mostly from the user base. So I would dearly want to see some comments from a cPanel and WebPros perspective. So if you're available to give a couple of comments, then I would be truly happy.
Sure, yeah, I can give some comments.
You have a loud voice, but I still think I'll give you the microphone.
Okay, so in terms of the release cycle, I recognize why you want to do the quicker release cycles because of procrastination reasons or maybe keeping your eye on the goal and getting it accomplished faster. But for us, and the overhead that we have to put into implementing each new version, I cannot feasibly reserve that bandwidth. So I can't use those. They're not usable for me. Where it is usable is when we do the LTS releases. Those, but even those, I can't. It's a struggle for me to get new users onto those. I think that right now the majority of our users that are using MariaDB are still using 10.3. I don't know the solution for that. It's a constant battle. So I do understand your reasoning, but I do know that for us it's really difficult to keep up with those.
No, I mean, there was never any illusion that like cPanel or any Linux distribution except for one flavor of SUSE, which is using ordinary, say for which one. Anything else, they will only use LTS release. We realized that from the beginning. So yeah, that's what we knew will happen. But you're getting high quality because you have faster releases and more testing. So this is good for you.
Yeah, I mean, more testing is definitely always a good thing.
I would agree, we have less testing and less stable releases, and things get more and more delayed. And because of this thing that we had relaxed, can get pushed, I get constantly told I can push in the release, and it has to go to the next one, and then I just forget about it.
So I have a question. It seemed that in the slides it was mentioned that the plan is to have the new LTS every 2 years. Oh.
No, that's current. There's no plan. We haven't decided on the next one.
Okay, but you know, at least it was. I swear it was on the slide somewhere.
Yeah, it was said how it is now. Well, we haven't decided about the future.
Okay. Well, the question I was going to ask is that I noticed, like between 10.6 and 10.11, there's 5 releases, and between 10.11 and 11.4, that's another 5 releases. And I was kind of expecting it to be 8 instead of 5. I don't know, it just seems a little.
Should I shout or I can?
Sergey, I'm coming.
Yeah. Yeah, right, because according to current release model, the new LTS will be 11.7, well, next year.
Okay.
11.3 is the last one we have now, and next LTS is 11.7. Unless we also change the model, but within the current plan, it's 11.7.
The other day, Mark mentioned he was thinking.
So now we're collecting more user customer opinion, and we have well, Andrew perhaps wants to comment first, but then I will give the word to first Ionos, and then Elisa, if you have some comments, overall comments, your observations. But first, Andrew.
So yeah, I'll put a WordPress hat on briefly and say part of the reason why the bug counts are low under the new model is only about 2% of MariaDB users actually use any releases of the new model at the moment.
So I mentioned that in the room we have user representatives, and Ionos, perhaps you have some top-level comments, and then I will give to a local user customer here in Finland, Elisa, as well, the word.
Yeah, actually we kind of have the same issues with the new release model like cPanel has. For example, we also use maybe the long-term support versions just because we need to have some time to prepare the releases for our customers and bring this up and running, and then after some time the next release comes, and then it's just the platform is so large that we need always a lot of time to prepare it, and so for now we're still staying with the long-term releases only.
Do you have the same problem of getting people off of the end-of-life ones? Oh, well, that was a comment and a question rather than.
Yeah. So I think one of the summary comments here is about users wanting to stay with LTS and sort of offloading the QA and testing cycle to to somebody else, but what's the Elisa view?
Yes, hello, Dmitry from Elisa. Yes, I agree on the same motion that we kind of stay in the old version for a long time. For example, we have 10.3 running right now, and we are moving just to 10.6. So that's LTS versions, and we try to stay in them for as long as we can. So maybe the emphasis on the features is not so important to us as it's more important the bug fixing, because we tend to find some bugs from time to time. Thank you.
Monty.
Related to that, so why 10.6 and why not 10.11? Which is also
That came too fast. 10.11.
But
Fast, yes.
But really, I think Monty's question is quite relevant. So now that you are updating, why don't you go to the newest of the LTSs?
Well, because a lot of time was used for testing this 10.6, and we just got that tested in different software. And now the new versions came, and we have to start this testing again. I cannot just put it in the production.
Okay, because you already have done testing. That answers the question. Thank you.
I'll hand the microphone to Sergey again.
I have actually 3 comments. First, this thing with preview releases, it guarantees a certain amount of time dedicated to bug fixes. That is, it guarantees that there never will be time when everybody is working on new features and there will be no bug fix. So this is guarantees some, well, minimal level of bug fixing always happening. Second, yeah, so we did look at what other software are doing. For example, this kind of reminds Fedora rel model. So Fedora is like for enthusiasts and playing with it and stuff, but users of the kind that we have in this room, I mean, like Cipanel, Ionas, and Elisa, they of course would go to, they would not probably use it if Fedora would use CentOS or Hell Enterprise or something like that. So this is that thing. And the third one, maybe we could use LTS, we could release LTS less than every second year if it takes that long to upgrade. So maybe 2 years is, every second year is too often. What do you think?
So actually we could take a vote, and of course engineers can't vote, but who would prefer 1 year before 2 years? We're not directly working.
So 1 year, I see Eric.
I mean, you are the one who can vote, so you would prefer 2 years. Sorry.
Two or even 3.
Between releases.
Even 2 is too short.
So you want to have releases less often?
Less releases makes it easier for me to implement because I have to take a whole team's time for maybe 2 or 3 sprints depending on what you do, what changes.
But what's the problem here? Assuming we have 10.4 will be a LTS, you don't have time to do it, and then we do 10.6 LTS, and then it's your time to decide which LTS you use. Why don't you directly go to the latest one and just ignore everything in between?
Because most of the time we've already started implementing the one before, and then we go to the next one when it's ready. So also my users don't upgrade, right? So I have half my users wanting to use 10.4, and then the other half are like wanting to go to the brand newest thing. So if I don't get both of those in there, I have people complaining.
So you would prefer, I mean, we do it one release every 10 years, because then it would be much less work.
So that would be the best way to ensure all users on the most recent version, but I don't think that's realistic.
And Elisa?
So I'd like a commentary soon from Daniel here. We have a big user in Wikimedia Foundation, and Wikimedia Foundation was on very, very old releases, but they did make a bigger jump, and they are making bigger jumps now. So I think this question from Monty, if you are moving anyway, why aren't you updating to the newest one, is being answered by, yes, we are going to the newest one, if you are Wikimedia Foundation. Okay, that's of course just one installation. It's not like the cPanel scenario. Sergey looks unhappy.
No, don't know how big a jump it is.
Sorry?
Don't know how big a jump it is.
So they were on 10.3. So Wikimedia Foundation was on 10.3 and we're worried about moving to 10.4. And then suddenly, the next time we met them, their upgrade was from 10.6 to something else. No, I will not speculate about numbers. I will give it to Daniel. Daniel knows it all. I wanted him to say this anyway.
Okay, so as Marco beside me just confirmed that Wikimedia were on like 10.4 for a very, very long time. They built their own compilation and pushed that out, so they're actually, they're not actually following distros, but they've actually got, I guess, the similar distros and service provider requirements that they will do it slow, they will do it considered, and their stability is of utmost concern. They, in the last year, maybe slightly more, have done a very slow transition to 10.6. I don't think it's fully in production. There's probably replicas out there, but I think their right workload is still on 10.4. So they really like, it was like it's the end of life, eventually impending of like 10.4 that kind of moved them forward. But yeah, they're very slow and conservative and doing so in their usual kind of 5-year cycles, try to keep with that. Anyway, so Sally.
I thought that they were testing 11. I saw some tests. But just in testing.
Yeah.
They are testing 10 of 11.
10, yeah, as a favour, probably more than, in intensity.
Well, I just want to say something on behalf of MariaDB PLC customers, because I have a feeling that you guys here are talking about Wikimedia as an exception. It is not. Most of our customers, I would dare to say 90%, care about stability and not about new features. And even 5 years release cycle is way too short for most of our customers. And that's why Monty, they will not start jumping to 10.11 within next 3 years or so. We have a lot of customers using 10.4, 10.3.
Sally talks with a lot of customers. I do too. You have two kinds of customers. Those who are really happy with what we have now, or those who really, really need these features and they didn't know and they can't wait 3 years. We will not get them if there's a release every 3 years. Because when our salespeople start talking with them and they say that here are the requirements, do that, and they will say, okay, we go back after 3 years. We don't get those. So it's much better, in my opinion, to satisfy customer requirements to do release early, yearly, so that we have something that they need. And also, DBS will upgrade to the release I tell them to do if there's a feature that they really need.
But it will take them 1 year.
Yeah, but the thing is that we can implement that and they can start planning when we start implementing. So when the release is ready, they are ready to move, as long as we can provide good testing environment so they can guarantee the quality of the release. So it's a question also that from business point of view, we have to do a release every year. Otherwise we don't have business.
Just one small comment. There is thing we all call features for many customers are bugs.
I'm talking about new things.
Yes.
And even bug fixing it can be a feature if you haven't fixed it for 5 years.
Yes, but a customer says this is a bug, not a feature.
And then you have to fix it in the current release.
Yes.
So I think it's, there's an insight coming clear here. There are two completely different requirements on the release cycle that needs to be reconfigured. One is the one where stability is the priority number 1, 2, and 3. And that's not the scenario that Monty is primarily advocating for. Monty is advocating for a scenario where new functionality is needed, and that type of customer or user is not represented in this room directly. It is represented by developers and by Monty. So I think when we have the homework of looking at the roadmap for MariaDB, what we need to understand is how to cater to the cPanels and Ionoses and majority of customers, users represented by Salle of the world, and then those who are pushing MariaDB forward, and that's why we are here. We're here about innovation and getting new things out there to the user base. And it's not as if they would want a feature without stability. They also need stability, and I think those are the requirements that we need to match. Would Sergey have a commentary on this? No. Would Monty have a commentary on this?
Yes, I always have a comment.
And then I'm giving to you, Jonas.
I think we are mixing two different topics. Stability and new releases. They have nothing to do with each other. Stability is something we just have to fix. And the current release model doesn't fix that because we don't have any user testing at all. And that's actually where we see the real bugs coming in. There's almost no usage in practice from 10.11 or actually anything intermediate. Also, the current release models, we can see we have much less features per release than we ever had before. And actually even between 2 LPSs. So we need to fix this. With the alpha, beta, gamma, we had you can see the release notes. It's 4 times more, something like that. This is very, very fun. But the main thing is that I think that to be active, we can't tell a user with a bug that they had to wait 3 years to get the bug fixed. And that's the reality now. And in this case, a bug that somewhat changes the semantics a little bit, so you can't add it to GA. You have it to add to the next one, and they can't wait.
Oh, okay, I thought you would. So, Anna, you were saying somebody was wishing to comment. Oh, sorry. It wasn't I also was Sivan.
And you have mail.
So, I guess I have a question about the problem Sergey mentioned about having too many branches, too many merges. If you guys have a new long-term supported release every year, and if each one of those is supported for 5 years, does that become kind of a nightmare for having too many different branches you've got to backport fixes into and stuff, or no?
We're doing backward. We basically always push bug fix in the release and post it. And that is still not end of life, and then it works out. We do that. The nice thing is that our code base doesn't change much. We don't do refactoring that causes things to move around. So rebase is usually always accepted. So managing, I mean, basically I have during the whole lifetime of my school MariaDB, we have had yearly releases until recently, and there have been no notable problem in maintaining those. But now we have 4 times more releases. And that's putting so much constraint of things that I basically ignore in the releases. And I don't do merges because I don't have time.
So I'd like to give the word to Mason Sharp, the VP Software Engineering of MariaDB PLC, who inherits these very, very interesting scenario and requirements that are not always pulling in the same direction. So any kind of commentary from you?
Yeah, I would love for us to find some kind of a consensus on this, but on this I'm kind of team customer / team Monty on the yearly releases. I thought the presentation was really interesting, and I think though in terms of development, so maybe the solution is a little bit of a hybrid where we do the year, and this is just spitballing, a hybrid thing with the yearly releases, but if sort of internally those quarterly blocks of development time have helped us internally stay on track, we can still sort of do that internally as a process, but still perhaps do the yearly releases at the same time.
So that's like a sort of partial commit and a partial view of where to go. So I think this is a peaceful time in going forward with the internal session, and by internal I mean one where we move those people who are interested in the release model and how to get features out there to the user base with some kind of release schedule, also known as release model, to the Pavlov room, and then here we will continue. Monty still wishes to say something.
A little bit before saying that I need to have a discussion with Sergei in this.
Yeah, so Monty wants to have a somewhat internal discussion before everybody's moving there. Do we have a...
We have now Lucas now.
So we have Lucas now, so we'll give the word to Lucas, and the topic is...
Assembling a performance and security toolbox for MySQL and MariaDB.
I will let you say that once again, so happy to get you here.
Here and okay. Where do I stay? Like in this area? Not here.
Give it just a second, so some people move to another room, then you have more peace.
And more here. Yes. Okay, very great. So, welcome. This will be performance and security optimization talk.
Can you quote them on the back? Thank you.
Okay, so I'll start anew because everyone's listening now. So this talk will be a performance and security optimization talk, and as you can obviously see from the title, we will try to assemble a performance and security toolbox for both MySQL and MariaDB. And this talk will also be applicable to Percona Server. And I will start with the fact that performance optimization talk. because in this talk what we aim to do is we aim to optimize performance when you have a lot of data. So let's say 10 billion records, maybe 20 billion records or even more. So if you have a lot of data, this is the talk for you. So to begin with, I would like to pick your brains a little bit. On the screen right now you can see two queries. The concept behind those two queries is there are full text queries, as you probably already know. And if you run MySQL 5.7, one of those queries will time out or crash your server, and one of those queries will run just as usual. It's actually a bug in MySQL 5.7, and we have actually discussed this concept within some of the members in this room. And we came to a conclusion, the reason why MySQL does that is because kind of full text indexes are kind of their own internal world in and of itself. And the reason why it times out is because, I'm not sure if you can see, but we have, in the second query, we have an eta sign. We're searching for an email address which has an eta sign, and the eta sign makes the query time out. As stupid as it may sound, but that's the case. So now that you have a concept, a taste of this talk, what's coming through, so I should probably introduce myself because you're probably wondering who is this guy and why is he on scene. So I write database stuff, I write security stuff, I run breach directory, which is a data breach search engine which lets you search for your email address, whether it has been exposed in a data breach. I blog about databases, about security, I blog a lot, Archetype, DB Visualizer, Redgate, pretty much everywhere. So that's very great. So now we get into the talk. So we're going to go through performance basics, then MySQL engines, and then how to optimize schema and data types for bigger data sets, how to optimize your tables, your databases for big data in general, and how to take backups of big data sets because MySQL dump will not work. And we're then going to go through some advanced features and some interesting features and some bugs as well. And then finally we have tools to help you improve your database performance. So very great. So we're starting from the bottom, and to optimize your databases for big data, you obviously have to know the bare basics of performance. So obviously everybody knows that, but we still have to start here. So first thing you have to do is you have to configure your service via MyCNF. You have to optimize, DB storage engine. You have to only search what you need. So the less data you search through, the faster your queries get. That's very, very obvious. You should probably use InnoDB, which is the primary storage engine offered by MySQL, because it's ACID compliant and it can also be twisted in ways that you probably didn't know were possible. We're going to get there in a second. And the last thing you have to do is you follow performance best practices, right? You follow normalization, indexing, partitioning if you need to, whatever. So the first thing to do is to choose a storage engine that runs big data sets. So this is where you have a couple of choices. The most obvious and the most probably primary choice would be InnoDB or XtraDB. In some cases you may be able to use MySAM, but MySAM should only be used if you have a very big table that you want the row count to. So basically, since MySAM stores an internal row count and InnoDB does not, count queries will obviously complete much faster than InnoDB, but that's the only use case of MySAM these days. And yeah, so now we get into optimizing the schema. Now I would like to firstly mention there's no need to innovate. There's nothing very new that you need to do here. There's nothing like revolutionary that you need to do. Stick to simple data types, as simple as you can get, the simpler the better. Index what you need to, index your select queries. Obviously keep in mind that indexes slow down updates and obviously deletes. Normalize your tables, obviously if you have a lot of data, normalization helps. And partition. So partitioning, again, it takes space on the disk, but it makes your select queries faster. Now, first interesting thing is you can enable the SQL mode's strict trans tables for automated truncation of data. So if you're inserting data and you need it to be automatically truncated without errors, this is what you can do. You should probably avoid text data type, not because it's a bad data type, but because it takes a lot of space on the disk, and the more data you have, the more space it will take, obviously. And obviously you should switch it to char or varchar, but if you switch it to varchar, you should keep in mind that it takes data obviously as well, so it takes the length of bytes of your data plus 1 or 2 bytes, whatever. So if you have tens of billions of records, obviously it adds up very quickly, so this is something you have to keep in mind. Next thing you have to do, after you decided on how to optimize your schema, you have to optimize the database for big data as well. The first thing I have to mention here is that insert queries will not work, not in the case that will crash the server, but in the case that it will take just a lot of time and you probably don't have enough time to just insert 10 billion records into your database. So you switch insert queries to load data in files. The reason why is because insert queries have a lot of overhead in and of themselves, and load data in file, it skips all of that overhead and lets you insert data. And if you insert data with load data in file, you can insert it in bulk, and you can use the buffer pool to MySQL's advantage, and your files will be significantly smaller than if you would have 10 billion insert records in them, insert queries in them, yeah. So load data in file in and of itself has a couple of options. You can specify a character set, you can specify what your fields are terminated by, what character, probably this is the primary option you will use probably, what lines are terminated by, and so on. And if you use partitions, you most likely will use partitioning by range. So this is a very basic example, but it will work depending on what you're building. So if you're building a search engine, for example, if you search for accounts, if you, for example, search for data that has letters or numbers, even if you have like tens of billions of records, this kind of partitioning setup will most likely work, as long as you have the same partitions for all of your tables you're querying, so that your queries are quick. Actually, don't forget that you can use a max value for the partitions. Max value is basically anything that's not specified. So if you want to have a partition specifically for like other values, so this is what you can do. Now, the other thing you have to notice is that big data sets are very different thing than ordinary data sets, and they work differently. They make MySQL work kind of differently as well. First thing you have to notice is alter table functionality, and you have to keep in mind the space you have on the disk, because alter table, how it works, for those who are not aware of it, is that it makes a copy of the table on the disk, it reinserts the data, and then it swaps the two tables that you need to alter, right? So that means that if you have like a table that's like 100 gigabytes in size, and you use an alter table on it, you have additional 100 gigabytes in size of the disk. Like it will take additional 100 gigabytes in the disk, and if you run out of space, your query will obviously not complete. The next thing is you can sometimes use the default clause as an update clause. Now what I mean by this is that if you create tables and you use a load data in file to load data into those tables, so that you load data in a bulk fashion, a quick fashion, you can actually specify a default clause for some of your columns so that you don't have to run update queries after your data has been inserted. So let's say if you have a column that you know all of those values in that column will be X, so you can specify the default value of X when creating that column, and then insert data excluding that column with load data in file. You should probably use UTF-8 MB4 instead of UTF-8. For those who don't know why, is because UTF-8 in MySQL is not really UTF-8, because it's only supporting 3 bytes per character, if I remember correctly, while UTF-8 MB4 supports 4. And actually you can use alter algorithm instance to instantly add columns to MariaDB tables as of MariaDB 10.3.2, as you can see here. So that's very useful as well. Now to backup data, now it's a different thing as well, because if you have billions of records, MySQL dump will not work as well, because not in the sense that it will not work, will crash your server, but again, it takes logical backups, so it takes insert queries, as it backups insert queries to basically rebuild the data. And insert queries is something that you again want to avoid, because insert queries again they come with overhead and you want to switch them to just data itself. So the first plus of doing this is that obviously your file is smaller because it doesn't concern, it doesn't have insert queries in them so much. And the second thing, MySQL will obviously load data faster. So basically what you do to take backups is you create a script that has select all into out file, queries, and loops through all of your tables. And then you have the backup. This is the most likely, most fastest scenario that you can use, I think. And obviously to restore that, you can use load data in file so that it will be restored quickly. Now, advanced features, as I said already, you can use default as an update sometimes when you're loading data into your tables. And if you're in a situation where you have like 15 billion records and you need to remove duplicates out of those records, you can use a unique index, right? Because it will work, but it will not work again as quickly as it should because you have billions of records and MySQL obviously has to deal with them. So what I would suggest is you use the sort option in Linux. It has a unique flag, so basically the U thing. And you specify your data, where your data is, and then the output file. And basically the sort with a unique flag, it will remove all of the duplicates out of the file, and then you can use load data in file to load this data in, which is very great because it takes little time to do that. If you have to use insert queries, you can also use insert ignore to ignore all of the errors posed by you, for example, not having enough columns that you insert in or whatever. And you can also, if you need to, you can delete data according to time periods by using for portion of time period, as shown here. And you also need to remember that if you need to delete all of the rows in a table, truncate is significantly faster than delete. And you can, if you're using MariaDB, you can obviously use a query explain plan and then kill queries if necessary with the kill query if they take a lot of time. Now, tools to optimize database performance in this way is probably the first tool will be you, because you know your database most than, better than everybody else. So if you follow the advice that I gave you, you should probably be good to go. If you are after tools that help you optimize your performance, your security, there's MariaDB Secure Installation, of course, MySQL Secure Installation that helps secure your installation. There's the slow query log, which you can use to obviously have an insight into your slow queries. There's MySQL Enterprise Edition where you can use the firewall if you want to, or other things. And there's also tools like SQL clients like DB Visualizer or Archetype. There's Redgate Monitor, which helps you monitor your database instances. There's Cluster Control. There's also a database monitoring tool, and so on. So now we have a bunch of interesting stuff. So does anybody know what the Schrödinger's paradox is? Yeah. Okay. So Schrödinger's paradox is basically a thing that does exist but does not exist at the same time. So the concept of this thing in databases is that you may have a situation where you have, let's say, where you're inserting data, your electricity goes out, and then you want to drop that table that you inserted data in. MySQL will show that table in a show tables query, but if you try to drop that table, it will say this table does not exist. So what do you do then? What do you do then? The most easiest solution is to grab different MySQL instance, just recreate the structure of the table, and then grab the FRM file and then just copy and paste it to your real server. And this is how the problem is solved. So I hope you enjoyed this talk. I hope it helped you a little bit. I hope it was interesting for you. And I am down to answer questions if you have anything for me. Thank you.
What would make MariaDB easier to use for you?
What would make MariaDB easier to use? let's say if we have a section about in documentation for bigger data sets, which I didn't find anywhere. So if we have a specific section of about bigger data sets, that would be very cool. That would be, I think, not only for me, but for some other members of the community as well. It would make MariaDB easier to use as well. Any other questions?
Roman.
Yeah, I agree, because it's naturally related to the column storage that is about all that process. So I don't really have a question, but I have a suggestion if you're open to it.
Yeah.
To take out the huge data set, one needs to always use -q attribute for MariaDB client. Otherwise, it ends up buffering all the output result on MariaDB side. And imagine it's a couple billions or something of denormalized IOT table. So it basically crashes MDB when it goes out of memory, because it will try to buffer it on the server side. So it's always a must when you are trying to output it. As we discussed, if I'm not mistaken, 2 days ago, we are pushing the new syntax for load dating file, so it will be able to take data from either S3 or other URI resources directly. So this should help a lot, because you don't need to load the data directly on your computer to be able to ingest it into MariaDB. In modern world, it's just a must also, because all the data is either on CDN or on S3. So these were my bits.
Okay. Does anybody have any other questions, suggestions? No? Okay. Then I guess thank you, and we will proceed to other talk.
Actually, it's lunchtime.
We can talk at lunch.
Stop lunch. It's a video.
I think
what light is it?
Hey, it's a right first half without any breaks.
The most open source as possible.
So that conflict. What's going on with that?
No, it was like that, starting from 2014.
Just easy to
Shared with the community.
So, well,
I think it's not necessary.
welcome back after lunch. We're now starting again for the afternoon. The first session is recorded Edu Melendez Gonzalez, improving DevX with test containers and MariaDB. So please, Edu.
Hi everyone. Today we are going to talk about improving developer experience with test containers and MariaDB. We are going to start talking about testing in general, then we are going to introduce test containers project, and finally we will be doing some demo using MariaDB and test containers and see on the first hand how you can improve the whole experience using both technologies. My name is Edu Melendez Gonzalez. I am software engineer at Atomic Jar. I am also test containers co-maintainer, Java champion, and you can find me on social networks as Edu Melendez. So, how many of you have been in this situation? Of course, probably most of us, where all of our unit tests works great, but when we are writing integration tests, if we do some, then we have some failures on those. Or if we have some continuous integration environment, then we are detecting those failing tests on that environment and not in our local machine. Right? This has been pretty common in the past, where we put a lot of focus on unit tests instead of integration tests. And probably everyone is already familiar with the test pyramid, which basically what it says is let's put most effort and do more on unit tests, which is at the bottom of the pyramid. And then we are going to add integration and integrate tests, just a little of those, because of some reasons, such as which ones runs faster. In this case, unit tests are faster than integration tests, but of course there are some trade-off. And in the past, those trade-offs were basically resources. So if you're not familiar with it, you can check the link. But however, in 2018, Spotify released a blog post, and they were talking about test honeycomb. So the test honeycomb put focus on integration tests instead. And as you can see, there are also implementation detail and integrated tests. There is a difference between those, and I really recommend you to read the article. However, they also mention in this article that they are using test containers for integration tests. And you probably wonder, why integration tests? And since we are talking about MariaDB, a database, then probably there are a lot of things that we do against it or using it. For example, I am pretty sure that most of the applications that you use or you build at the company, it's at least integrated with a database, right? In this case, MariaDB. So you need to test how your application or the SQL statements that you are using on your application against MariaDB. If you are adding new features, how you are testing those scripts those scripts migrations, are you using any specific tool? For example, in the Java world, there are tools such as Liquibase or Flyway, which allow you to do those migrations. What about database migrations? What if you are moving from MariaDB 10 to MariaDB 11? How can you make sure that those applications will work without any issue? And also, service configuration. For example, let's say that your database in production has a specific parameter which allows you to set all the columns and tables with uppercase instead of lowercase. And what if I, as a developer, I am writing on lowercase? So I will not be able to catch those errors until I deploy my application into a real instance. However, if I write an integration test using a real MariaDB instance with that specific configuration, then I can make sure that my application will not fail for that reason on production or staging. So there has been some approaches in the past regarding to integration tests. It has been pretty common, for example, to share instances. However, it has been very costly, right? Sharing instances, like having a dev environment pretty similar to QA or staging environment. And besides, it can cost a little bit of effort. It's also, it can be a little bit worse, let's say, because those instances, as the name says, are shared across different teams and can be polluted in data. So the effort to maintain it is very high. The other approach is local installation. I remember those days where I was installing my whole applications locally in order to use it at some point, not to test it like all the time, but to use it to make sure that the query that I am writing it makes sense or not. However, it's a little bit like context switching between your IDE, the database, and the workbench that you are using. Other solutions are in-memory solutions. And for some basic stuff, let's say, it will work, like select statements, insert statements, create table, probably some of them. Not all the instructions will work as we wish, because in-memory solutions only work around basic functionality. It's only the real instance, the real product or service that you are using, and which will provide with the whole features that you want to use, of course, in your application. And finally, when Docker appeared in 2013, it offered also a solution which was which is Docker Compose. Docker Compose will allow you to spin up real instances of any solution that is in a container, and then you can use it in your application. It's good. However, there are some drawbacks related to this, and we are going to talk about those when we will talk about test containers, which is the topic that we are going to talk right now. There are some implementations. Sorry, I forgot to translate this one. And there are some implementations in different languages. The first one is Java, and then we have other ones such as Go, .NET, Node, Python, Rust, Scala, Haskell, Ruby, Clojure, even. And Atomic Jar is the company that is sponsoring the first 4 implementations. So let's talk about test containers for Java. Test containers in general is an open source project. Test containers for Java is built using Java 8. So if you are using any other version, such as 11, 17, or 21, which was released a couple of weeks ago, then you can use the project. It has also integrations with different testing libraries, such as JUnit 4, JUnit 5, and Spock. And test containers use the Docker API, not the CLI. So you don't need Docker CLI installed. You just need the Docker engine installed in order to communicate, in order to use test containers and those APIs. Well, what test containers offers? It will automatically detect the Docker environment. So for example, if you are on Mac and if you are on Mac using Docker desktop, then there is a rootful and rootless socket, and both of them are detected by test containers. If you are on Linux, there is a rootless installation, there is the Docker engine, and there is a Docker for desktop, and those three has the socket in different locations. So those three locations will be detected too. And in Windows, if I remember correctly, if you are using WSL, then it will work too. Test containers allow you to handle the container life cycle. So for example, if you want to make something or do something before the container start, or after the container start, or before the container stop, then you are able to do thanks to the API that the project or the library offers. Also allows you to configure the container and the service. For example, if you want to copy some files, scripts in the case of the database, if you want to set the username, the password for the database, if you want to restart the service, we are going to see one example using MaxScale in the demo and MariaDB, and how you can control the life cycle and configure the service in order to use it for your testing purposes and development purposes. And it also offers the automatic resources cleanup. It means that if you are using, in this case, MariaDB container, then you will start the container before all your tests will run. You will run the whole test suite, and then at the end, it will stop the container and it will remove the container, because test containers relies on ephemeral containers. So you can just throw away those instances once those are has been used. So why use test containers? Because you will be testing against real instances. For example, if you, some examples that I mentioned at the beginning were like my application, the queries that I write in order to perform against the database, the scripts in order to migrate to the next feature. What if I am using Kafka or a message system which has some connectors which will consume or insert data into my database? So I can test those implementations if I am using a real instance and make sure that it will work, and even document the process and the configuration that is needed in order to make it happen. With test containers libraries, you will be running tests, not containers. What happened with the Docker Compose that I mentioned before? If you want to, you have to basically follow an instruction which says, in order to run this project, you need Docker, you need to have the following Docker Compose and then run Docker Compose app. However, with test containers, the only thing that you need is Docker, and then after that, just run your test suite as you used to do, nothing special. You will get the clone and run experience, of course, because someone say, okay, you need to start in this project, so give me the GitHub repository, I will clone the repository, and then once I run the test suite, I will make sure that everything is working as expected. So that's the whole clone and run experience that test containers offers. And it also allows you to do local development against the real instances that you are spinning up. And about that, I will talk a little bit later. So another reason to highlight test containers for integration testing is because the project was also mentioned on the ThoughtWorks technology radar, in which they say you can enter to the link. Our teams have consistently found this library of programmable, lightweight, and disposable containers to make functional tests more reliable, because you are testing with real instances. And test containers, of course, offer different modules. What are the modules in test containers? Are basically pre-configured setups for containers. We have some modules for databases. As you can see, MariaDB is right here. If you are using some message brokers, streaming platforms, then there are also modules for those technologies. If you are testing database credentials with Vault, for example, a HashiCorp product, then there is also a module for that. If you're in the cloud space, then you can also test against the emulators. And something that I would like to talk or mention a little bit is how test containers is used beyond testing, which is local development, one of the items I mentioned just a few minutes ago. For example, those are the three most used frameworks on the Java world. Quarkus, it offers dev services, and Micronaut, it offers test for services, and Spring Boot just call it test containers integration. And those approaches allows you to spin up your application along with the dependencies that the application requires. For example, if I am building an application and this application needs a database, MariaDB, then the application will also start the container thanks to test containers. And you will have your application running because this is pretty similar. In the containers, in the integration test space, we will be writing just some tests in order to make sure that those features are working as expected. However, there are some cases in which you want to test locally, like spin up the whole service and test that everything is working as expected to. Maybe there are some tricky scenarios that you cannot catch easily through the integration test, and you need to manually do it first and then write the integration test in order to cover it. So in the Java space, this is how the frameworks, the top frameworks, are taking advantage of test containers. So Atomic Jar is the company behind test containers, and it has also released a test container desktop application. And you probably wonder why. There are some benefits. Probably if you are already using Docker, you are you are evaluating Docker, probably because of the license thing. Well, Atomic Jar is offering Test Containers Desktop with an embedded container runtime, which was just released last week. This is still experimental and it works on macOS, but it is pretty nice to have an alternative. There are other alternatives, but this alternative, of course, is it has been built with test containers in mind. So you don't need extra setup. You just need a click in order to say, I want to use the embedded container runtime. And that's it. It also allows you to use to switch through containers runtimes if you want, if you have more than one, for example. There are also some experiences from the community, and those features has been added in order to address those the feedback. Freeze container shutdown. For example, there are some cases in which we need to access to the container and see what happened, understand the reason why my test was failing, because probably I copy a file or script in the run directory, or I execute some commands and one of those fail. I don't know. There could be any reason. The last one I had, it was just helping a community member, and it was he mentioned that he was not able to run the simple measures transformer in Kafka. So he shared with me a reproducer project. I was taking a look, and of course, if you run the test will be very fast once the container is up. So I froze the container shutdown, so the container was still running, and then I was able to access to the container through the command line, and but I was checking a lot of things, and then at some point I said, okay, let's check the Java version, because in the report it was said that Java 17 was used. However, the container was using Java 11, and that's something that probably at the beginning it is you will not be like guessing about that, but we identify what was the issue in that case and fix it. And the other one is the proxy container. There is a proxy container port offering a fixed port for development experience. If I am using test containers, and this is something that I forgot to mention, you will be running all your services against random ports. So it will not be using 3306 in case of MariaDB. It will be offering a random port, and this allows you to run containers in parallel and other things. But if I am working on my machine locally, what I want is to use my local tools against MariaDB, right? So instead of fixing ports on your test, we are offering a configuration file externally from your application in order to offer those fixed ports, and all your tools, your local tools, will be working against the different containers that you are running. We will see this in a demo in a few minutes. And well, finally, let's go to the demo. So let me switch here. I have a project. It's a Java project built with Spring Boot, nothing fancy to be honest. So let's write a simple application, a simple test first, okay? This is a simple test using JUnit 5 in this case. So let's do this. Okay, what I have done here is I am declaring, oh, thanks Copilot. I am saying this test will use a MariaDB container with version 11.1, and then we are going to start the container, and just let's print first the URL, okay? In order to see what's the URL that you are going to use in order to connect to the database. It's not the one that you are guessing. Remember, it will offer you a random port. So as you can see, test containers connects to Docker, to Docker. In this case, I am using a test containers cloud, a solution offered by Atomic Jar. And the test pass, of course, because I haven't asserted anything. And as you can see here, this is the JDBC URL, but the port is different. It's a random port. So far, how can you make sure that this is working against the database? So here, I have a script. It's very simple, nothing fancy. Create table profiles, and then just inserting one record, username Edu Melendez and email edu@example.io. What I am going to do now is copy this file with the test containers API. So now MariaDB container will be also containing a database script in this location. MariaDB image over this location in order to put those scripts, and then it will be automatically applied to the database. We will start the container, and then, well, I already have some things in place here. So let's create a connection, prepare statements, execute, get the result set, and then make sure that the username column contains Edu Melendez. So if I run it as is, it will fail, of course, because those three are incorrect. So MariaDB get JDBC URL, MariaDB dot username, and here MariaDB get password. Because as I mentioned earlier, test containers offers pre-configured modules. MariaDB is one of those modules, and you can get access to it through the MariaDB container. I forgot to mention, but if you are using Java, and Maven in this case, then you can get access to the MariaDB module with this dependency. What else? Okay, now let's make the test file. I am going to add an X here, run the test again. And as you can see, it's going to start the container first. And of course it fails. It's expected because what I was expecting is Edu Melendez, not Edu Melendez X. So now let's rerun the test and it should be green. So with that example, we can make sure that the container is starting. The script is copied to the container itself. It has been executed, and from my side, I have wrote the select statement and then make sure that the script was applied by asserting the username. This is one way to use it, and for example, here in Java, by doing this, by putting the MariaDB container inside the try is called try with resources, and it will make sure to close the container at the end or destroy it. However, if you, for some reason, need to do a different approach, you can do something like this. Sorry. Okay, something like this. Delete this one. And then at the end, you can do MariaDB stop. And then it will be the same result. But take into account that we are programmatically using or controlling the container. We are saying start here, stop here. And this can be done, and in this case, it will be only in the scope of the test, right? So what happens if I have more tests using MariaDB, just one instance? For example, you can say static here, and instead of starting the container, you can just add the before all, after all methods and remove them from the test, and then it will still work in this case with this only test, but if you have more, then other tests will be using the same instance. So you are starting the container once and I don't know, running 2-3 tests with only one MariaDB instance, and then it stops. I also mentioned that it has integration with JUnit libraries or testing libraries. In this case, JUnit 5. So I am going to remove the life cycles for JUnit, and I am going to annotate here test containers. And here I am going to use container from the test containers library. And in this case, this annotation, it will recognize all fields annotated with container library, start the containers at the beginning and stop when those when all the tests have run. So if we run this test again, it should pass one more time. Okay, fine, it has worked. So let's do something a little bit more fancy. Let's use max scale. I mentioned earlier about this, and I am really excited about doing this test. So the first thing is that in Docker you can create networks and you can link those containers through the network, and those can communicate to each other. So we can do this also programmatically. For example, I am going to define a network, a Docker, a network, test containers network. Let's define again the MariaDB container right here. Okay. Let's use the network in the container. Okay, so MariaDB will be using this network, and other containers can call NDB. It will be the network alias for MariaDB container. And now I already have something with max scale. Probably it will be easy to read. So I have max scale right here. And I am going to use the test containers integration. So I need to annotate my containers with it. Test container. Okay. So what max scale is doing is it's going to use the MariaDB max scale image with this version. It will expose the port 17017. There is a wait strategy, and the wait strategy says mark this container as ready once this message has appeared once in the log. There are other wait strategies that you can check, but we will be using this one for max scale. After that, since what we want to do is connect both containers, then we are going to assign the same network to max scale, and we are going to use a specific configuration. Okay, we are going to say copy this file from my class path max scale conf to etc max scale conf. So something that I almost forgot is copy my script, but not this one from the database. It's other one. And this one is right here. So the only thing that I need is put add max scale user, and yeah, you can use whatever name here, but I am going to use the same one. Okay, and now I am going to show you what is doing this script. Basically, it will create a user and it will be granting privileges to the user that has been created, nothing more. The max scale configuration, the important part is, well, the address here is using MDB because MDB, remember, MDB is a network alias for MariaDB backend. And we will be also adding the MongoDB listener. So yeah, that's it. And you probably wonder how I am going to run this script right here. And well, I mentioned a couple of technologies such as Liquibase and FlyWyDB. In the Java world, those are libraries that are in charge of database migration. So the library is right here. And once my application starts, then the FlyWyDB in this case is going to be in charge of executing those scripts. So something that I missed, it was what are you doing here, right? Like explaining this section, this piece of code. And as I mentioned, you can control the container lifecycle. And one of this is, once the container has started, then please execute one command in the container, which is max scale restart. Why I am doing this? Basically, I follow a guide from the developer hub, and I was using max scale, of course, and I read that once you copy the max scale configuration, then you need to restart max scale. That's what I did, but programmatically, I didn't. I basically automate all the steps in order to do this. So what I am going to do now is, well, this is something more related to Spring itself. You don't need to worry about it. Auto-wired JDBC. Okay, I think I need the JDBC template too. I do not remember correctly. And the other one is, okay, dynamic property. Okay, I need something like this, but for MongoDB. Oh, well, for the NoSQL listener. So here is that MongoDB host and that MongoDB port. Okay. So in this case, I need max scale, get the host, and we can do this, okay? But since we are only exposing one port, we can do also get first map port, okay? And you probably wonder why you are not doing that for MariaDB? Well, because I am using this annotation, and well, due to the Spring Boot test containers integration, I don't need to do that for MariaDB. So I only need this for containers that are not aware from Spring Boot point of view. So with this, we are saying, okay, we are going to use the MongoDB API through MaxScale using this host and this port. And now I need, okay, I need to hurry here, but I will be using MongoDB template in order to insert some data right there. And sorry about this, but I am going to copy paste some records, which basically is the data. And this is what I will spec on the test. Okay. And this is the query. And guess what? Try to test this query with an embedded database. I am pretty sure you will not be able to do, because those are a specific MariaDB syntax. And you can, as I mentioned at the beginning, if you want to test against whatever against MariaDB features, then you will be able to do that only with a MariaDB real instance. So in this case, I am using not only the JSON statements provided by MariaDB, but I am also configuring MaxScale with MariaDB and how they can talk to each other. So what I am going to do right here is, yes, you already know, Copilot, what I am doing here. So I will execute, thanks to the JDBC template, map the whole result set against the full profile, and then I should get 2 records. Why 2 records? Because I have 2 social networks, remember. Edu Melendez is one profile, but one profile, it will contain 2 social networks. So the way that I did the select statement, it will return 2 of them. So let's run the test, right? In this case, I don't have the max scale, so image locally, so it will be downloading the image first. So as I said, you don't need to worry about the image or the container lifecycle or the resources that you want to use on your test. Test containers will provide everything for you. And as you can see, also in the test, not only the image is pulled from Docker Hub, but also Flyway migration has been performed successfully against the database. And well, the test passed, so everything is fine, right? So let's make it fail, yes, so you can believe me. Yeah, it fails because it doesn't, but yeah, elements not found, right? So it doesn't match the return from the query with what I have been expecting. So I have another demo to do. It's, but it's not right here. So I will be running it, and then I will, we will share the links later. I will run it on the shadows. It's basically the same, that I just need another configuration for that. Also programmatically, which involves all the code that you have seen in this test, just put in other places. But since we are running out of time, then I will run it on behalf. Okay, so now I will show you. This is the application in which, as I mentioned, it's basically the same, creating a network, defining the MariaDB container, max scale, and what else? In this case, I am inserting some data, which is similar to what we had in the test. But in this case, we just run the application. I will stop it right here. I will run the application. This is not a test, it's an application. Okay, MariaDB, max scale is starting. And as part of the application, where is this? It will be, sorry. Yeah, it will be just inserting some data and printing some other data from the full profile repository. So as you can see, there are two records and this is only printing on the console, right? But this is my application running, right? So I was also talking about test containers desktop, and there are some features. For example, this one, which has a MariaDB, as you can see here, configured through 3306 and max scale through 8989 and the NoSQL listener. So what you can do is, since you want to see if everything has been working as expected or experience a little bit about it, we will be exposing the console through a fixed port, not the random one. Remember, test containers use, in your code, you are using random ports. However, using test containers desktop, everything is proxy through fixed ports. So you can go to MariaDB, admin, MariaDB, then accessing to the console, see the MariaDB monitor. And if you want to, this is one option. And if you want to use your local tools, for example, here, I will say, let me open the full console. So for example, here I will show you first the configuration, okay? Properties. So localhost 17.17, MariaDB T3.06, everything through local, okay? But I am connecting to the containers actually. So for example, if I run here, you can see the ID, the class, and also the social field, the username field. If you go to also through to MariaDB, then you will be getting access to profiles, right? Edu Melendez, and then you can also access to the networks, because that's the thing with MaxScale and MariaDB, that you will access to non-SQL data as a SQL data and using the JSON instructions in order to get the data out of it. So if I stop the application, then we will be also stopping the containers. So as you can see, there is no more container nature here. Yeah, it will be thinking because there is nothing running behind. And well, I have some examples in my GitHub repository. You can find like many of them. Also using dev modes too, if you want to access through the QR code. And also resources, the Java test containers documentation, the getting started with test containers, the module catalog, containers, test containers cloud. And remember that Java is not the only option. You can use it with Go, with Node, with .NET, and any other language. And if there is no module for that, then you just create your own. Well, you can chat with the team in the Slack channel. Also go to the repository and the website. So thank you so much for having me. Bye.
Q&A session and no live edu here, so we're moving directly ahead to Christian Rosen to get some feedback from Ionos and get to see to your presentation that you've prepared for us. So I am excited to see, and let you first.
With the title Single Sign-On from MariaDB using proxy users. During my talk, I would like to discuss proxy authentication in general and how we at Ionos used it to implement a single sign-on feature for our shared hosting customer databases. First of all, let me introduce myself. My name is Christian. I'm 36 years old. I'm living in Karlsruhe in the southwestern part of Germany. And during my free time, I'm a hobbyist photographer and musician, and I'm very interested in all sorts of animals, especially reptiles. My professional career started around about 11 years ago when I joined the database team at Ionos. At that time, I worked as a working student and started implementing some database automation tools, starting with user management for MySQL databases. My current job position, I'm the technically responsible for the whole database platform, and we currently support MariaDB, MySQL, and PostgreSQL. We are operating database for internal purposes, then for customer-facing products, and also for external databases, namely the shared hosting database platform. And in total, we have around about 4.6 million databases that run on a little over 9,000 Linux servers. Now, after introducing myself, just a few words about IONOS as a company. We are Europe's largest hosting provider with around about 4,000 employees in 35 locations all over the world. And IONOS operates almost 9 million customer contracts in several different markets. In our 10 data centers, we house over 100,000 servers and over 22 million domains. Our product portfolio includes all sorts of internet-related products like domain and SSL, mail, office collaboration tools, like for example cloud storage, website builders, classic web hosting products like shared web hosting, WordPress hosting, and also server and cloud related products. So now let's have a close look on how the talk will be structured. First of all, I'm giving you some context. I will define the scope and tell you for which products it's actually relevant. Next, I'll have a close look at the objectives that were to be achieved. After that, I'll give you some details about our implementation and our failed attempts on how to get there, and how we finally reached our goals. In the end, I will draw a conclusion, and then there will be also probably some time for questions. Initially, the talk was planned for 30 minutes, now I have a 45-minute time slot, so I guess there will be plenty of time for questions. So how can everything that I'm going to talk about be included in our product portfolio? I'm going to focus mostly on the shared hosting platform. That's where customers can have a classic web space, some databases, and then implement their own projects on top of that. And for this product, we manage, as a team, completely manage the whole database platform. This infrastructure is quite large. We run over 4.5 million databases on that at an average of 2.8 million queries per second. And this then results in around about 150 gigabits of network traffic on a daily average. And the whole thing is using around about 280 terabyte of disk space. The whole platform is designed in a fully redundant way. So in order to provide those databases, we actually have to pay double the resources that we actually need. But therefore we can easily survive even the outage in the whole data center without a lot of downtime. Traditionally, MySQL would be one of the most popular databases for web hosting environments, and we support both versions that are currently available, MySQL 5.7 and also 8. But since some time ago, we also support MariaDB as our new default DBMS. For adding MariaDB, we still had some challenges. They are caused by the internal provisioning of our databases, but I'll cover those challenges in the next few slides. So let's have a look at what we are doing and why we are doing it. And some years ago, the decision was made to renew the whole shared hosting database infrastructure to make it more future-proof and flexible. And this whole initiative was embedded in a bigger project to revise the whole provisioning for shared hosting products. And also at that time, the decision was made to exclusively only support MySQL 5.7. One of the main goals was to have a very good customer experience, and so the decision was made that it should be possible for the customer, once logged in our control panel, that he could also use PHP-admin without providing any further credentials. So just imagine, The later other use cases also were added. For example, customer care also needs to be able to have a way to connect to the customer's database, just to help in case the customer needs some advice or asks our support. There are a few obvious ways on how to achieve that. So somehow you need credentials to the database, so why just not simply go there and take the credentials of the customer, install them somewhere, and use the credentials then to create connections to the database. Yeah, I think it's already obvious that storing passwords of a customer somewhere is not the best idea, and also your security department would not be too happy with you when you go that way. So yeah, that's already a big no-go. The next solution, which is also quite simple, would be just create additional users for the use cases. So create an additional user for PHP admin, create additional user for support tools. But yeah, then the downsides would be that it can be quite complex when new use cases show up. And also you still have the problem that you have to store passwords somewhere. If you store the passwords, they can still get lost, and this is definitely nothing you want to have. So why don't you just make the users only temporarily available? So you need a user, then create a user, use it for quite a amount of time, and then remove it again. But then just imagine a customer logging into PHP admin, creating a view on some tables, and then afterwards he logs out of PHP admin. Eventually the database user gets removed again, and the customer has an invalid view which you cannot use anymore. So yeah, this is also not really a good option, because providing such an easy way to create invalid objects is definitely nothing you want to have for your customers. So this is also nothing we can or we should support. So yeah, and if you can't have any easy solutions, we also had a look at some other options, which I'm not going to cover now because they were not so relevant. And eventually, our dev team stumbled across a funny privilege that is often a little bit overseen, and it's the proxy privilege. And what this is and what you can do with it, I'm going to cover in the next few minutes. So just a quick excursion about proxy users. Proxy as a privilege is initially meant to be as a restriction for custom authentication plugins that implement user mapping somehow. So you can have a custom authentication plugin like PUM, for example, that implements the user mapping from some external sources, and then in the end you need to limit that somehow, that for example you have user A, it should be mapped to user B within the database, and the proxy privilege can then limit that user A can only map to user B and not to user C, for example. Yeah, it's only possible when the authentication plugin already supports user mappings, and the MySQL native password plugin does not. So yeah. And then came MySQL 5.7. With that version, Oracle implemented new features which allow you to create server-side user mappings, and therefore they implemented check proxy users and MySQL native password proxy users. Together with those variables configured, it makes it very easy to create user mappings by misusing the proxy privilege not to restrict user mappings from external plugins, but rather to implement them. And so it's not the very best solution, but yeah, our dev team discovered that and they found it really helpful. But first of all, I was not too happy with their designs, but after some discussions I had to admit that there was not really a better solution, so that's what they implemented. In the end, they came up with a concept that basically includes two types of MySQL accounts. One would be a so-called owner user, and the other ones would be then regular database users. The owner account would generally be the user that has all permissions on the customer's database. It can be locked so that nobody can use the owner user directly. And it also should be the only user that is set as a definer for views, triggers, and so on. Then there are actual user accounts. Those user accounts are that are used for actually connecting to the database, and also the main user of the customer is one of them. That's the only user which is actually visible in the control panel and should be used in the customer's own apps. Yeah, and then there can be other users with a limited lifetime, for example for PHP-Admin or some other tools. And those will be then short-lived. They will be removed from our provisioning after some time. And also those users will be then exactly like the main user, will be proxy to the owner, that no matter how the customer connects to the database, in the end it will be still the same user, the so-called owner user that acts on the database itself. With this design, you can basically avoid storing passwords anywhere, because those passwords are just generated once, connection is made, and then never really used again. Yeah, this is a very simplified illustration of how this could look like. So on the left side you would have a user that is then connecting to the database, then the user mapping takes place, and within the database only the owner user will act to create objects, to create the database, no matter what. Yeah. Here you can see a very basic example of SQL that is used to set the whole thing up. You have a database test.db, you have an owner user, owner 0815, you have a proxy user 4711. Yeah, I think it can be read. And as you can see here, the only user that actually has privileges in the database is the owner. And the proxy user itself only gets the proxy privilege to the owner user. As soon as you log in using that proxy user and you check the outputs of the user and the current user functions, you can see that the user function returns always the name of the proxy user, whereas the current user will refer to the owner. Yeah, then relatively soon after the implementation for MySQL 5.7, we got into discussion with our product management that it would be a really nice idea to also support MariaDB on the shared hosting platform as a nice add-on for our customers, or even as a default database. By the time already some customers were asking for it, so the discussion was not too long, and the decision was made relatively quickly to also implement MariaDB. But then the implementation we did years ago with the MySQL 5.7 platform became a little bit of an obstacle for us implementing MariaDB, because MariaDB neither supports check proxy users nor the MySQL native MySQL native password proxy users. At that time we got into contact with MariaDB, and even though they said that they would not backport the feature from MySQL to MariaDB, we still got a lot of very helpful feedback from them and suggestions on how we could achieve the behavior with stuff that is already in the MariaDB server. And we tested various solutions based on max scale, based on the role concept, multiple authentication methods per user, and we even reviewed something that only exists as a concept, which was the sudo. But unfortunately, nothing really supported everything that we needed. And so in the end, after some discussions, we came to the conclusion that MariaDB could support us with the proxy plugin, and we will then just sponsor the implementation for it. So soon after that, we got a working prototype of the auth proxy module, and this proxy module more or less implements the whole the same functionality like MySQL 5.7 does, with the check proxy users, and yep, it's quite easy to install. It's just a regular plugin. Put it into the plugin directory of your server, and then install it via install plugin or put it into plugin load. Doesn't really matter. It doesn't need any special configuration, and it provides the same, or more or less the same functionality like the MySQL 5.7 check proxy users does. And it fetches the user mapping information from the MySQL proxies brief table. This is more or less the same example like you saw earlier from MySQL 5.7, but this time it's for MariaDB, and we still have our test database, testDB, the owner user and the proxy user are more or less the same. The database privileges are still only on the owner user, and the only big difference is the creation of the proxy user, because now the proxy user needs to be identified not via MySQL native password plugin, but rather via the proxy plugin. But yeah, the rest is again pretty much the same. You can still use select user, current user to verify that the user mapping actually took place. It's still the proxy user for the user output and the owner for the current user. I just pasted in here a password hash, but it's not really a secure password, it's only AAAA. It's just there that you could use the slides eventually to set it up on your own machine. So yeah, what is the conclusion that we can draw from that project? With the new auth proxy plugin, in the end, we were finally able to offer MariaDB as an additional database to our customers, and we went even one step further and made it our default. So more or less every new database that is provisioned now is not MySQL 5.7 anymore, but rather MariaDB. And since the time when we introduced that around about 2 years ago, we already provisioned over 750,000 databases with MariaDB. And there was one big thing that we learned from that. Even though it's not really necessary, it's worth taking into consideration to create an index on the MySQL proxies brief table on the user column, because this is used quite a lot. And as soon as you have more than just a few database users, and with a few thousand, we do have quite some amount of users on our systems, it's a good idea to have the index there to speed up the login process a lot. We're even so confident with the plugin that we are currently planning on the migration of all our MySQL 5.7 databases, as this is getting end of life very, very soon. And we currently have 3.5 million databases that are very soon be migrated from MySQL to MariaDB. So even though we were using the plugin exclusively for the last 2 years now, it's it's going to be made public very soon. How exactly, we're not exactly sure yet, but it will come. And I think I'm already at the end of my talk, so now would be time for some questions.
Good thing with this proxy is free, but I didn't know that, so I can add an index for that for the next release. Will that cause any problems for you because if the index on user already exists?
No.
Okay.
Yeah.
I'm giving the mic so
Oh, yeah.
You said that you choosing MariaDB as default, and initially your implementation of MySQL was easier. So what was your main reason for deciding to use MariaDB as default rather than MySQL?
The decision was made because we wanted rather to stay on the MySQL, on the MariaDB track, because the direction with MySQL 8 is not so focused anymore on the shared hosting infrastructure. So we'd like rather to stay with MariaDB.
You don't have to finish any homework. But my question
Bring the mic because the virtual audience need to hear as well.
Okay. I was just wondering if you could tell us a little bit more about your like database servers and how you guys manage them. So how many instances do you have? How many users per server, stuff like that?
Overall, we have round about 9,000 instances, including the redundant stuff. For the shipping platform especially, it was pretty much the same like especially for internal databases. And we have simple systems, mostly asynchronous replication between two data centers, so two node clusters, and we have between 1.5 and 2,000 databases for instance. Any more questions? Okay. There are no further questions, then thank you for attending my talk, and I wish you still a lot of fun with the ServerFest 2023.
Thank you, Christian Olsen from Jonas. So now we have a schedule with the next presentation coming up, but that's not scheduled for right now, so I suppose we will have a break here in this room. If there's tea and coffee outside, you can go for that. Be back. Monty looks like you will want to say something.
There is cake.
There is cake, so Monty can have some cake and others too.
Okay, maybe that wasn't the last
They are quite steady with the checking lately. Totally possible to go back to minor replication. That costs yeah, then we have to do it for several days for the same card.
connector or connecting to a language that I'm fairly interested in seeing how we do with, and that's Rust.
Hello everybody, thank you for tuning into my presentation today. My name is Trevor Gross and I am going to be talking about plugin writing using the Rust language for MariaDB. This is something that I've been developing for the past handful of months, supported by Dan, and I just want to talk about what exactly we are doing, what the reasoning is, why we're doing it this way, and what we have so far. Now, I know that Rust is one of the newer languages, and not a whole ton of people have too much familiarity with it. So first off, I'm just going to show some examples of what it is at a technical level, what it claims, and how it can do what it claims. So, like C and C++, it's a language that's compiled to assembly machine code that does not have a garbage collector and does not have any sort of thing like Python's global interpreter lock, all of which make it a suitable language, again, like C and C++, for high-performance applications, like bare metal, kernel, databases, for example. Just generally, the whole design of the language is meant to prevent the sort of errors that you should not come across, that you should be able to prevent if you're a perfect programmer. But because nobody is, everybody creates these sort of mistakes. And what's unique about this language compared to C and C++ is it's able to provide the same guarantees of memory-safe languages like Go and Python, but it's able to do that with no runtime overhead. And the guarantees that it is able to make is no runtime undefined behavior. That sounds like a very tall order, but I'll explain it a little more in the coming slides. But first off, a bit of an example here, just to get an idea of the syntax. It kind of looks like C in a way. We have a struct, and we have a method on the struct that just multiplies two of its values, which is roughly equivalent to this C code, but just with some slightly less creative names. And as I said, the results wind up being the same. To give a little bit of credibility, take a look at where Rust is starting to get some popularity. And one of those places is the Linux kernel. It is the second language added to the Linux kernel, which is one of the biggest software projects out there that famously would not even accept C++. But as of the past year, you've been able to write kernel modules in Rust. Android is a very large C and C++ code base, but they've been attempting to write almost all new code in Rust, and they're also trying to convert some existing code from C and C++ to the language. Then Microsoft is also on board because just last week they released a way to write Windows drivers in Rust. So these are three really huge software projects that are starting to take use of this language that provides certain guarantees and just illustrates that it's kind of starting to grow. It's in a lot of other places too, like Firefox and Chrome. And as of now, somewhat MariaDB. I'm going to paint a bit of a picture now that shows what kind of undefined behavior it is able to prevent, and hopefully make it a little more clear how it's able to do things like that. I have a little C program here where I know the experienced C programmers will spot the error, but just basically I have a function that creates a struct which has a pointer in it. And I have a local variable, and I put a pointer to that local variable in my struct and return it. And then I try to print it, which works just fine because there's not much reason that it wouldn't. But then I happen to refactor my code or something like that, and I want to print it twice, but in between I need to call some other function, which just happens to use the stack. You'd expect these two results to be the same, but of course, the error is that we are returning a pointer to a local variable that doesn't exist and doesn't isn't valid as long as our return struct is. So we run into issues. And this, what I showed over here, was you can throw WAL at it, you could throw where at it, and still the compiler doesn't catch anything, doesn't flag anything as wrong. If we try to do this exact same thing in Rust though, so have a compiler that takes a reference and return a reference to a local variable, it's going to start yelling about lifetime parameters, which is interesting. This is the corrected solution in Rust, and I'm going to break down what exactly we're doing here. We need to add some annotations to show lifetimes. And you might have noticed that I use the difference reference and pointer. They're not exactly interchangeable because a pointer is, of course, exactly what it is in C, but a reference, in Rust at least, is a raw pointer plus some compiler time tracked metadata, which is that metadata is lifetime. So a reference is a pointer plus lifetime. And lifetime is how long something must be valid for. So in this example, we have to give thing a lifetime, and we just call it A. It can be anything, but letters are the default. All this is saying, it looks a little complex, I know it's new syntax, but all this is saying is, hey, however long thing lives for, call that A. Now, since the thing has a pointer in it, or since it has a lifetime, a reference, we need to give that pointer an annotation as well. And so we give it the same A annotation, and what this is saying is, hey, however long X lives for, it's got to live at least for lifetime A. So the overall idea that we're representing just within the struct is, however long your struct lives for, whatever X points to must live at least as long as that. Which is a very, very straightforward concept, but you can apply that to the C example I showed you, and you see when you don't uphold that, what can happen. And then I fixed the issue here, so we're returning, rather than a local variable, we are returning a reference to something that lives on the calling functions level, and of course it works as expected, and it compiles as expected. This code would not compile in any way that returns a variable that doesn't exist for as long as thing does. So that's just a simple, that's the kind of mistake that is just very easy to miss and just can't happen in Rust. Another thing that happens, since the compiler is aware of references to things and is aware of how long they must live for, there's another rule that it's able to enforce that is very, very useful in preventing undefined behavior. And what that is you are allowed to have any number of constant references or a single mutable reference to a piece of data at a time, but never both, never mutable and const. And this example will show why this makes sense. So what I have here is a vector, could be an array, could be anything, and we take a pointer to an element in that vector. Okay, and then we print it out. Debug's just a handy macro for printing. Then we clear the vector, and then we print it out again. Now, of course, in this example, it would probably work. It would probably print exactly what you expect. But there's obviously a problem here where you have a reference to something, and then you edit it, and then that reference is no longer valid. Rust will not compile this code because it knows that rule. What it's doing, without digging too much into the detail, is it knows that there's a time, in order for this code to work, if it theoretically did work, there would need to be a time where a const reference and a mutable reference to the same piece of data exist at the same time. And since it's aware of references and since it has this rule, it's able to say you can't do that and it will fail to compile. And that's a good thing because that prevented a kind of error that would be very serious. That could be a double free or any kind of overwrite error, and that would be a security vulnerability at the worst, or at best it would just be an annoyance to you. So once again, what we have here is the compiler is tracking where references point and how long they are used for, and it is able to enforce that there's no aliasing without synchronization. As a result, we have a few kinds of behaviors that are completely eliminated. But first off, a couple other things that the language enforces is, one, you cannot have references that are invalid. There's a different way to represent what we have as null pointers in C, But basically what that means is that it's impossible to not check for a null pointer kind of return value. And then a second thing is that there's a way to move data, or sorry, a way that when data is moved, it becomes invalid in the previous location that it was. So what that means is that we have a way to destroy data and make sure it stays destroyed, or move data and make sure you can't use it anymore, which prevents a whole class of errors that are really kind of easy to come across in C or C++, because even if you move something in those languages, even if you destroy something, your pointers still exist and you can use them accidentally, whereas in Rust, that is not allowed to happen. So putting all this together, we've kind of eliminated a large source of not just safety bugs, but a lot of sanity check kind of bugs that exist in software. So we don't have buffer overflow anymore. There's no seg faults or traps because references are always valid and checked. There's no data races from aliasing. That includes thread races because the compiler knows when you need synchronization. And there's no use after free or double free because you have a way to eliminate the usability of data after it should be out of scope. That's a whole ton of errors that are avoided, and it sounds like a very tall order, sounds almost impossible, but I think that it's kind of proving itself to be true and possible, which is how I come to MariaDB and what benefits the language has for a database. So originally, how I kind of got started with this was I had a need for some UDF and it didn't exist, and there weren't many libraries for it, but there was a few good supported libraries in Rust. So I started looking at what would be needed to interface between MariaDB's UDF interface and the Rust language. And eventually I developed into this crate, which it provides a standard interface. You could see a portion of it here for writing a UDF. And what the whole process was essentially me going through the code and finding out the nuances, figuring out the edge cases, what worked and what didn't work in C, and then finding a way to represent those in Rust so that you have things like invalid data can never be accessed, invalid states can never be represented because the compiler is able to check for them, and all in all, we are able to create a solution that is very, very difficult to misuse. That will make a little more sense, I think, when I start talking about the encryption plugin. But just to illustrate how easy it is, basically every time I see somebody mention a need for a UDF, I add a new one. And so I'm at about just 30 trivial UDFs, but these are just crates that exist in the Rust ecosystem, and it takes about 20 minutes or less to tie a crate into a SQL interface, and it's just so easy that it's guaranteed essentially to work the first time it compiles. And that's proven true more than once, which is very, very convenient. But in doing these interfaces between MariaDB and the Rust language, there have been some things that are difficult and some things that are easy. I kind of mentioned the easy things already, but interfacing with the MariaDB code base has been pretty easy, really. Like, it's got a pretty well-defined C external API for plugins, and the Rust language is able to use those effectively. And designing the APIs, once you have a good understanding of the code base, has been pretty straightforward because you know what needs to be represented well and what needs to be not possible to represent. Then using Rust APIs, as I mentioned, is pretty easy to the point that if something compiles, you can be fairly certain that it's going to work correctly. Building and testing is quite nice too because I have a way to mock UDFs, so that means I could test them completely offline without going through integration testing, and it's actually pretty easy. However, as I kind of hinted at, the hardest part is just understanding the code base in the first place. So going through the C APIs, seeing where everything lives, when is data created, when is it destroyed, and to figure out a way to represent that in a way that Rust can guarantee. So that means presenting data that can't outlive other portions of data, which usually exists in C documentation comments, or either you've got to find that for yourself in the code, but instead we have a way to turn those into REST APIs where that kind of information is just in the function signature. And so after you write that, you don't have to worry about it. But figuring out what these guarantees are is tricky. Moving on to plugins now, which will probably give a better idea of what I mean by that. What I have here on the screen is the MariaDB interface for an encryption plugin, where we have the context initialization, updating, finishing, and encrypted length. And I found a few interesting things while I was going through and creating the REST API. One, as you saw, is that it's very difficult to determine the destination length. There's a flag for it, but the D-length value is not initialized. It's just, it's meant as an output only value. But in order to figure out how long your destination buffer is, you need to read through 10 or more levels of code, which is quite complex and pretty tricky to see through. This is important because some encryption algorithms need an authentication tag, which means that the output data is longer than the input data. So there's a potential that if you don't properly check the output length, you could be overwriting past the allowed buffer, which would be problematic. Second thing is that, related to that, encrypted length is sometimes ignored, and this is represented with a flag, but you need to read pretty into the code to understand exactly what the flag is telling you. And then the third thing was, there are some cases that source and destination actually overlapped, which you wouldn't necessarily think that they do just looking at this API, but that could lead to some serious problems for cryptographic algorithms that expect source and destination to be non-overlapping. Now, just for the record, this is one of the things that I worked with the team to get fixed, so all of these things I mentioned are no longer the case. But just to give an example of what this looks like on the Rust side instead, and how some of those things would be able to be prevented, this is what the library looks like that handles encryption, or more specifically the module. And what we see towards the bottom here are 3 traits. And a trait in Rust is like an interface in Java, or kind of an abstract base class, but it's a collection of function signatures. So in this case, initialization, updating, finishing, and encrypted length that allow you to do an action, or allow you, actually you can implement this on a type that performs that action, is a better way to state that. So this is the encryption algorithm, and the information, as I mentioned, you get a lot more information out of the function signatures in Rust compared to other languages. We get quite a few interesting things. Number one, this is a result enum, which in Rust is a built-in type. And I didn't mention this before, but enums in Rust can have values stored in their variants. And you could think of it as a union or a void pointer plus a tag, something like that. So that means that your data can either be one type or the other, and they essentially overlap in representation. So a result type has a successful type and an error type. And what this is saying right here is that on success, you will return self, the struct, and on failure, you need to return an encryption error. And the same thing for update, you return an integer. Same thing for finish, return an integer or this error. But right away, we know exactly what kind of errors can be reported, as opposed to something like where if you return a null pointer in C, it could indicate an error, or in sometimes if the value is instead of 0, not 0, it could be an error, or if it's a negative value, any of these sentinel values are completely avoided because you have this result type, which makes it clear. In addition to that, though, we have, you can see this is the syntax for a buffer, or a slice as it's called, which is internally represented as a pointer and a length, but the representation here means that the compiler knows what the size is, and it forbids you from writing beyond the bounds of this buffer. So you aren't eligible to you aren't able to accidentally overflow it. But actually, I said that for the wrong one, because by default, everything in Rust is const, so references in Rust are by default const. This is the only mutable reference. This is the only thing that you could actually write. And so that's actually good too, that makes it absolutely clear. It's kind of the opposite of in C, where you need to go out of your way to make something const. Instead, you need to go out of your way to make something mutable. And that usually makes a lot of sense for how things go, because just looking at the examples here, every piece of data in these first two functions is const except for one. So anyway, we know immediately that we have an error type. We know immediately that we have buffers, and the compiler will make sure that we do not accidentally overwrite them. We know immediately about our mutability, and then based on that, because of the aliasing rules I talked about, where you can't have a mutable and a const reference pointing to the same piece of data, we know that source and dest are not overlapping. So those are 4 pieces of information that we did not have in the C API without reading through. So we just have a lot of information presented, and the compiler is going to verify those things for you too, to make sure that they actually get checked and that you did things correctly. Now, of course, nothing is good without documentation, so I have been, as part of my work, I've been making sure to make all the documentation up to date and pretty complete. And you can see this is what it looks like in the docs. This is just the overview here. Writing the interface was truthfully the hard part. I spent most of the time with the interface doing just a dummy encryption algorithm for testing, which just copied the input data to the output data. And then once I was satisfied with how that looked, I put in a cha-cha cipher, which is what's shown here. And amazingly, I was totally surprised by this, but the first time it compiled, it worked. So that was actually quite exciting, because it seems to be fairly robust as well. So there's now an alternative to AES 256 GCM, which is awesome. But this is what implementing a trait looks like in Rust. You implement trait for type, and then you provide the function signatures. Straightforward enough. In this case, it's a little complicated looking, because cha-cha is an enum here, meaning we can have one of multiple different types, either a stream or an AEAD. And the reason that we need to do that is because of what I mentioned earlier, where you may have some cases where you're allowed to append an authentication tag, and some cases where the stream input and output streams need to be the same size. So that's why we need to be able to handle both. But anyway, just a quick little overview, and something that seems successful so far, which is cool. A different kind of plugin for encryption, or not different kind of plugin, but a partial subset of an encryption plugin is a key management plugin. And one of the protocols that Dan was interested in is Clevis and Tang. If you're not familiar with that, Tang is well, the whole thing is developed by Red Hat, but Tang is a server and Clevis is a client. And there's a way that a Tang server can generate a key, and the client can mix it, and essentially the client winds up with an encryption key. No encryption keys are exchanged across between the client and the server, and neither can recreate the key without the other's help. So this is a key exchange, a somewhat new key exchange protocol that Dan wanted to support with a plugin. And he thought that Rust would be a good idea, because in order to do this, you need to do a few different things. You need the cryptography portion, you need JSON, because everything is implemented in Jose between Clevis and Tang, and you need to be able to do the network requests and everything. And it was a very good experimentation plugin for the first real use case that turned out to work quite well. We have a basic implementation for that, and I think that we will be trying to actually get it supported or get it to a state where it's shippable. To give just a quick overview of what this plugin actually looks like, this is the interface for Key Manager. So people who are familiar with MariaDB's encryption plugin are probably able to understand this already, but you need to be able to get the latest key version from a key ID. You need to be able to get the key itself and copy it to a destination based on a key ID, and then you need to be able to tell the key length based on the key ID on a version. And then this on the left here, what I have is how you register plugins in the REST interface. And it's a pretty nice looking interface, really, because you have everything together. It's a little more straightforward to understand than the current C version, where I think it's 2 different macros to start and end destruct and difficult to piece together. And it's pretty nice that you just have everything all in one place, names and all. Just looks like defining a struct with named variables. All in all, kind of coming to a conclusion with what we're working on, what we have so far is we have successful implementations to encryption and key management interfaces. We also have the user-defined function plugin working. And as I didn't really talk about here, but I mentioned, we have system variables working. We also have SQL service working, logging. The CMake build system integration is done, unit testing within Rust, and preliminary integration testing with MariaDB test. This is a pretty large subset of what needs to be done to essentially consider this project successful. And some of these things were kind of tricky, but most of them were pretty straightforward, really. So it's been quite a success thus far. Looking at where we go next with all of this, one of the things, as I had just talked about, was we want to make sure that we are able to potentially ship this Clevis plugin that is able to communicate with the tagging server and provide key management. Further plugin support would be nice. For example, authentication plugins I know were mentioned as well for similar reasons as encryption plugins. Data types are the interfaces to those are pretty substantial, a few hundreds of lines of code. But it would be interesting to see because there are very good libraries out there for things like MAC address handling that are pretty easy to use with Rust. And then one other thing that would be nice is the ability to create Rust plugins without having MariaDB source available. This already works for the UDF. You just need to provide the header files or the relevant header files converted to Rust, which is an automatic process. But then you're able to, because crates.io provides versioning for all the sources available, it's pretty trivial to request, for example, the 10.11 or the 11.3 version of interfaces that work with MariaDB, and then you're able to version your plugin to different interfaces without actually needing the MariaDB source available. And that's kind of convenient to be able to do because building is a little bit tricky sometimes. Another thing that would be nice is simpler UDF interfaces. I don't know if anybody's seen the Rust UDF interfaces, but they are a little bit tricky. But what we could do probably better is to provide a even more straightforward interface for adding UDFs in Rust. Probably not too many people have seen what the current interface looks like, but it's a little bit clunky because you need to specify the return type, you need to specify the initialization, and you need to specify the processing. And that's a little bit more than what most people want, because what most people need is a function signature that looks like this, and they don't want to convert it manually into the interface. I think with a little bit of code generation, we could make this possible without any extra work from the user. And the way that we do that is just with a more complex procedural macro. What those are is like this and this. Procedural macros are kind of, they're actually a run macro that they operate at a pretty low level. They get the token stream of the entire function or the entire block body, whatever they are applied to, and they're able to read all the information, read what the inputs are, read what the outputs are, and create something based on that. So what this procedural macro does is it reads all of this, and it creates what's needed for a C plugin interface. So it creates the statics needed, it figures out the names and everything like that. We would just need to take this one step further to make it so that you can write an entire UDF in 3 or 4 lines. which is pretty great, actually. Another step beyond that would be something like what Postgres currently has, which is pretty awesome. It lets you use, in the function creation, specification of a language. PL Rust is one such language, and it allows you to write native Rust functions as part of a SQL query. Now, that's kind of nice because you get the advantages of the speed and performance and interfaces to everything that you would get with a UDF, but you get the simplicity of just being able to not need to worry about loading a plugin and going through the steps of compiling separately, because you just write it once, you write it like a stored procedure, and it could be a one-off small function, doesn't really matter, but it's just easy to do in a few lines while you've got the server running already. And another benefit to this is, of course, because Rust, it has its safety guarantees, you don't need to worry about, you couldn't necessarily do something like this with C. In theory, you could, but it would be rather difficult. You'd probably crash the server quite a bit while trying to write something that works. But with Rust, because of the safety guarantees, because you know you're not going to accidentally dereference a null pointer or accidentally write to some data that you're not allowed to, you know that you're not going to crash the server. You know at compile time, whenever this PL language gets compiled, that everything is going to be okay and validated. And that's just one of the very nice things that could be integrated. MariaDB actually has support for this language keyword, but I believe it just is not connected to anything at this point. So that sums up my presentation, and we come to a conclusion here. Basically, what we have is we're looking at taking a new language and seeing how it can incorporate with what's already there, add some benefits, and perhaps make things a little bit easier for any users who want to get into plugin development but don't want to delve all the way into all of MariaDB's source code to figure out what their plugin's doing. They just want to look at the interfaces and know where to go for there.
Opening for many things to happen within MariaDB. So you did me a great service who didn't know more than the sort of top line about Rust. You explained why Rust is good, but the reasons that you provided for why Rust is good is also in my mind providing the reason for why we need to do a couple of the things that you were saying. And in a way, I think this Q&A is a bit you doing the Q and us doing a bit of an A. So I would want to give Daniel Black the word and see what your commentary is on this.
First of all, thank you very much for taking a process that was just a concept and actually transforming it into reality. So much appreciated. You give me far too much credit. You did a lot on your own, and I really appreciate it on that. So I guess on the first question before I run to the audience is on do you know how the Rust integration in Postgres works? Is it compiled after you specify the language?
You're talking about from the last slide here. Let me see if I could share my screen just briefly so I can pull up the presentation again. Oh, never mind. Host has disabled screen sharing. You're talking about the specifying the language and being able to use it in a SQL query?
Yes.
Yeah, it's a type of plugin, I believe. I'm not exactly sure how the internals work, but it is essentially just sending that off to the Rust compiler, or the plugin's invoking the Rust compiler, and then it creates an object file or a dynamic library that then is immediately loaded. So it's just kind of all in one. It's a one-step process to do what a UDF does, but you're able to do it. You're able to have the server invoke it and then load it right away. Just a bit of a simplification of things.
Okay, thank you. Anyone got a question?
Federico. Hi, Federico here. I lost a piece of your talk, so I hope I'm not going to ask something you already said. First of all, thanks and congratulations. This is a great talk about something very useful, but I think that using UDFs for something potentially complex has security problems. For example, if you write your UDF that calls a remote API, for example, it could lead to problems, and basically I think you don't have a way to restrict the usage to only some users. Do you agree? And if so, what? I don't know if you hear me.
So yeah,
Yes, but,
you're asking.
keep going.
Keep going.
So you're asking about the once again having it used directly in.
Sorry, but your image disappeared. And basically, I hope you're still hearing me. And I wanted to ask you if you have some solutions for these kind of problems.
Okay. I can hear you all right. Yeah. Hello. It sounded like the video cut out for a minute. My video. Are you able to hear me still?
We don't hear you.
Hello. Anything?
Yes.
Network issues.
That's our Trevor, say something.
Oh, I'm talking.
No.
Only if we.
And now?
And without.
Hello. Can you hear anything?
Yes, now we can hear you.
Nothing? Oh, you can hear me?
Yes, now we can hear you. Yes.
Oh, okay. All right. Not sure what happened then.
Oh,
and are you able to enable screen sharing? I don't know if that's.
Yes,
a
I
quick...
can. Just a second. I make you a host, and then. There. Now you should be able to do it.
Okay, just a second. Yeah, I'll pull this up. So once again, thank you to whoever was asking the question. Are you referring to this kind of PL Rust example here? When you were talking about the security concerns for any user being able to execute one of these?
Potentially, yes, but it's a generic question. I mean, for example, if I have a UDF that does something potentially dangerous, like calling an API or something, well, I wonder if you can suggest a way to avoid that it's used by anyone. So, for example, I could restrict. Ideally, I could restrict the usage to
install plugins
is
a privilege. Installing plugins is a privilege operation. So,
yeah.
Yes, exactly. I mean, it's the same. You could do arbitrary code execution with a binary, so it's the highest level of trust in a system that you can possibly have. So everything offered here is really just making it easier for elevated users or people who you do already trust to do things that they can perhaps be a little more confident in, or just know at compile time that you're not going to run into some potential unexpected security issues. But that doesn't mean, of course, that somebody couldn't write a UDF that is malicious in intent and does do some things, or even, of course, it can just be something that's incorrect accidentally. So there is, with anything where you're loading a plugin, there's a level of trust that you need to have with the author. And of course, this doesn't offer anything new here, aside from the fact that perhaps they can do it a little bit easier or with a little more confidence than what's currently available. Was that responsive?
yes, absolutely. Any other questions?
You're closer.
Sorry.
Yeah, just a quick question. Thank you for the encryption work. I was reviewing it. I think this is a good direction. But I was wondering, is there any need for tools like address sanitizer or undefined behavior sanitizer for Rust programs?
touch too much on it, but Rust, as an example, you have to, if you are interacting with C, or you're allowed to do all the things with pointer manipulation and everything else that may be considered limitations, but they need to happen within blocks that are labeled unsafe. And what that basically says is, of course, you're doing operations that the compiler is not able to verify. And one of the places where that needs to be used is the interface with C. And so I need to use, as far as actually being able to connect this with C, I do need to use a lot of unsafe code. And as a result, that is one thing that the compiler cannot see through. And yes, I do compile with ASAN and MSAN, and I run that in CI. So there is definitely a place for ASAN, MSAN, but actually the things that the compiler checks is a superset of what those are. So ASAN, TSAN, MSAN, UBSAN, you're kind of getting all of the positive effects from that without even running it through. And then there's actually another tool for Rust specifically. Unfortunately, you can't run it with C, called Muri, which is an undefined behavior checker that it's like a runtime for a middle representation of the language, and it tests for those things as well. But again, all of that is only needed for the unsafe code, essentially, because that's the places where the compiler cannot give you a guarantee. But the entire language is based on the concept where if your unsafe code is sound, the things that you have to hand verify, then the rest that you can build on top of it without safe will be sound code. So that's kind of how the relationship is. Does that seem to make sense? Or?
Yeah, sure. I was just wondering if you have pure Rust application, is there anything, and you mentioned there is still something that could be verified at runtime. Everything cannot be done statically.
Yeah, for the most part, it's because this is just an interoperational layer, there isn't really that much that can be verified, but I do still run it for a proof of concept. And if you were running a larger project where you had more unsafe code, then I would definitely be running it with ASAN and MSAN just to be a sanity check for that. But then the other thing is true as well. The deeper you have Rust in the stack, you don't need unsafe code unless you're defining new data structures really, or if you're interoperating with FFI for C. So the deeper you're using the language, kind of the less need for that there is. Not that it's ever a bad thing to compile as a sanity check, but it does not find anything in safe code that's incorrect usually.
Okay, thank you.
I wanted to ask, where can I find the code that you were showing earlier?
The UDF code or the plugins code?
The plugins code.
Okay, so I can send some links to, if you're on the Zulip chat, I'll send them to the general channel.
All right, thanks.
One is because the UDF suite is, if you're looking at using the UDFs, that is a published crate, so you can just, if you're familiar with the build system, you just type cargo add UDF, and then it pulls in the dependency. And if you're looking at using plugin code, it's in a fork of the repository, if you're looking to review that or test it out or anything.
Yeah, that's the latter is kind of what I wanted to look at.
Okay, yeah, absolutely. I'll make sure, I'll start a Zulip stream and put a bit of collection of information together for this.
Thank you, Trevor. Anyone else with questions? Okay. Can I give Trevor a thank you very much?
Yeah, thank you everybody for attending and for the questions.
Okay, hello, I'm Marko Mäkelä. I'm the lead developer InnoDB at MariaDB since I think 7 years or something like that. I started with InnoDB 20 years ago, first at the InnoBase company and then at Oracle. And today I'm talking about the undo logs and the purge of transaction history. So the outline of my talk is why do we have these undo logs, and what is the purge of history, and what is the purge lag? Why should you care about this, and how can you avoid or mitigate this purge lag? And how to reclaim the space that is or was used by undo logs. How the transaction metadata is stored in InnoDB. And then a section about some recently fixed bugs and ongoing work on performance. So what are the undo logs and what is the purge? And why do we have the undo logs? Well, InnoDB is designed so that the transactions can be arbitrarily large. In some other storage engines like Myrox or Aria, there is no separate undo log. There is only a write-ahead log that is written when the transaction is committed, and until the transaction is committed, everything must be buffered in memory. InnoDB doesn't have that. InnoDB writes, for durability, it writes this circular redo log, and that has a limited size, but InnoDB is writing the changes as it is making them. So during the execution of transaction, InnoDB is already writing the changes to the data pages and to undo log pages. And transaction commit basically is a simple operation that only marks the transaction log header as committed. And this is one reason why we have undo logs. Basically, no matter how small our RAM size is or how small our redo log size is, we can have arbitrarily large transactions. Another reason is that there is no limit how old transactions you may have. You may start a transaction, and with multi-versioning, that transaction will see the state of the database as it was at that point of time. No matter how many transactions are committed afterwards, this transaction will see the state as it was when it started, or when its read view was created. I had a previous talk a year ago about this, how this MVCC works in detail, so I will not go into that. And yeah, obviously, if you need to roll back a transaction, then all the changes will need to be undone, and that is of course done by this undo log records. And this may be part of a crash recovery. If the server is killed before the transaction is committed, then the transaction will be recovered as incomplete, and then its changes will be rolled back. And similarly, if you have a two-phase commit, XA start, XA prepare, and server was killed before XA rollback or XA commit, then these transactions will remain in the XA prepare state until an explicit command to rollback or commit comes. Now, what is this purge? It's basically garbage collection of the undo logs of committed transactions. So yes, the transactions can be arbitrarily large, which means that we have no limit on the size of the undo logs for a particular transaction. And it also means that when the transaction is committed, it must not discard the undo logs immediately, because we may have those old read views that need to be able to construct the state of the database when those read views were created. So we must defer the cleanup of commit to this purge process. And these MVCC reads, they must unsee these changes done by the commit. And it may be that you have started a review like an hour ago, and purge would be blocked for all transactions that we were committed in the last 1 hour. It could be a huge amount of undo log that needs to be purged when that oldest review finally closes. The review, we have this purge sys.u, which is the clone of the oldest review, it says it gives a permission to remove history, but that removal doesn't happen immediately. We have these purge threads that are doing it, but it may take some time, and it may even fail to keep up with very write-intensive workload, and that is the purge lag problem. So how to avoid the purge lag? I think the biggest problem with the purge currently is secondary indexes. In the cluster index or in the primary key index, we only have the latest version of the record with the primary key. And then we have the undo log pointer pointing to the undo log to get the previous version. But in secondary index records, we don't have that transaction ID in each record. And we actually have multiple secondary index records. If you modify an indexed column, then there will be a copy of each value of that indexed column in the secondary index. So you may have lots of records, extra records in the secondary index, and when you are accessing the secondary index, the code must look up the primary key and check if this secondary index record actually exists in our view. And purge needs to do the same. So this can be very expensive. And this can lead to a kind of a death spiral. If you get a lot of purge lag, you will get more of these extra records in the secondary indexes. Everything will be slower, including purge. And that's why we definitely must do something about this purge lag in the code. There are some mitigations that you can do as a user of the database. If instead of using the default isolation level repeatable read, if you use read committed, then it will create a new read view for each statement instead of using one read view for the whole transaction. And if you use read uncommitted, then it will not create a read view at all, which means that the purge will not be blocked by a read view because you don't create one. So purge will be allowed to proceed even though you are trying to read something. You don't really care if it's consistent, you just need some data. And another thing that as a user you can do, you can enable the bulk insert interface that was introduced in MariaDB 10.6 for InnoDB. So if you set unique checks 0 and set foreign key check 0, then it will, and if you are inserting into an empty table or partition, then the table will be exclusively locked, and InnoDB will only write one undo log record saying that if this transaction is killed or rolled back, then we truncate the table or partition. And this is of course much nicer because for purge there is nothing to do. We only see this record, okay, if this will be rolled back, then truncate. Well, purge is never executed on something that was rolled back, so purge will just ignore that record. And we will have fewer undo log records to deal with. This is good when you are loading data into the database. And then there are some tweaks to parameters. You could try them, but I don't know if this could be that the cure is worse than the disease if you enable this throttling of DML operations. The idea of these parameters is to slow down inserts, updates, and deletes if the purge is lagging behind. This logic was recently improved in MariaDB 10.6 so that it doesn't unnecessarily slow down those operations. It used to be so that even though there is an old read view that prevents purge from running, it would still delay. But now in MariaDB latest 10.6 and later versions, we do not do that unnecessary delaying. But still, this is just a workaround and a hack. It does help a bit to reduce the purge lag, the history list length growth, but it's not a really acceptable or good solution. We need something on the code side. And then one section of my talk is how to reclaim the space that was used by undo log pages. You probably know or used to know that InnoDB system tablespace never shrinks. And by default, the undo log records are written to the InnoDB system tablespace. So if you had a burst in your workload that caused lots of undo log records to be written, and you had a lot of purge like in the history, and if those records were written to the system tablespace, then you used to be out of luck. But now, thanks to my Indian colleague Thiru Narayanan, something, I don't remember his last name, we call him Thiru, he has done most of this work here. He allows his changes in MariaDB Server 10.11 or Enterprise Server 10.6 allow you to change the number of InnoDB undo tablespaces on an existing database. So that if you do a slow shutdown of the server, and then you can change these InnoDB undo tablespaces to move the undo logs from the system tablespace to these dedicated tablespaces. That will prevent further growth of the system tablespace because of undo logs. But it's still not the whole solution. One more thing in MariaDB Server 11.2 was that you can specify an auto-shrink attribute to the system tablespace, so that any free pages at the end of the system tablespace can be shrunk so that only the last allocated page in the system tablespace will remain. So this will allow the database to shrink. It's not the perfect thing because we don't know what is in the last page, and we don't move pages around to make it shrink more, but it's definitely a step into the right direction. And this is done only on server startup to limit any problems when the server is running. Then we have this old mechanism, InnoDB unlock truncate. I think it was added in MySQL 5.7 and MariaDB 10.2. It works so that if you are using these dedicated undo tablespaces, then it will choose one of the undo tablespaces for truncation, one that has exceeded the specified maximum size, and then it will block any writes to this undo tablespace. Transactions will use other undo tablespaces except this one that we have chosen for truncation. And once it has sort of cooled down, everything in this tablespace can be purged, then we will truncate and rewrite this tablespace and move to the next one and allow writes to this one. In MySQL, there is a separate log file for this undo tablespace truncation. In MariaDB, we are using the InnoDB write-ahead log, and this allows concurrent backups to work without problems and simplifies crash recovery. Now, how the logs are stored. There is in the system tablespace, page number 5 is the transaction system page. It's on the left side of the slide. It has a pointer, it has 128 pointers to this rollback segment header pages. The first one is hard-coded to be in the system tablespace, and the rest can be moved to these dedicated undo tablespaces. And when you are, this is basically for compatibility reasons, we are reserving the rollback segment 0. I didn't dare to change the file format there, just to play it safe. So basically, if you are using multiple undo tablespaces, you are using these 127 rollback segments for your undo logs. And in each rollback segment header, you have an array of pointers to the start of undo log for each transaction. You can have a limited number of concurrently active transactions. I think it's some hundreds of thousands, and it depends on the InnoDB page size. And once the transaction is committed, it will be moved from this, the undo log segment header will be marked as committed, and then it will be moved to the start of the history list, which is here on the right side of the slide. So a committed transaction will just move to the purge list, to the history list, and that's what the commit does. It's a very, very simple operation. So now I'm going to mention some recently fixed bugs and some performance work. We were considering to enable this undo lock truncation by default because we made multiple undo tablespaces default in was it 10.11 or 11.0, and at the same time we were considering could we automatically truncate or by default truncate the undo locks. We decided against that because it would cause some performance reduction, and it could be better for users to have control when they think that they can afford some extra load on the server. But we found some bugs when we were testing that. A couple of bugs were that the purge was actually running too early. As a result of this, a concurrent read could get a crash when it's accessing an undo lock record, because the undo lock page would already have been freed and reallocated for something else, and the undo lock record would have been overwritten by something else. And then there were some regression due to fixes of these bugs. It's a rather complex code, and it was quite tricky to understand all implications. So there was rather embarrassing bug that we didn't catch internally, that InnoDB would kind of leak pages in the undo tablespace or in the system tablespace. It would never free the undo lock pages that were actually already processed. That was fixed in a unscheduled release. And then we got a rather improbable hang, a deadlock. I added some checks against the redo lock override when doing this undo lock truncation, but I had forgotten that when you are calling this redo lock check function, you are not allowed to hold any latches that may block page writes, and that's why this check had to be moved to a little bit upper level. It's a bit inaccurate. If you are using a very small InnoDB redo lock, you can theoretically, if you have bursted workload, you can have an unrecoverable server because of that. But normally the recommendation is to have a redo lock about the size of 1 hour worth of writes. So you shouldn't normally run into that. And then there was a bug, an older bug, that if you enable the InnoDB undo lock truncation and the undo locks are already logically empty, there is nothing to purge, then it would fail to truncate the undo tablespaces. They were basically all full of garbage, but it would not truncate them. Then there was this one, also an older bug. It was quite interesting. I used the RR debugger for this. We use that for internal testing. So about 1/3 of the InnoDB test runs are with the RR tool. It's basically recording the whole execution of the server that was killed and the next server that was started and so on. So we get the whole trace from the start of the test to the problem, and we can debug everything in that trace. So we found a funny case where there was a crash or there was a restore of a backup, and after that we got a crash when the server was starting up. And the reason was that we had a recovered transaction that needed to be rolled back, and then it was an empty transaction that was being committed because InnoDB works in that way, and then it was changing something, and the purge subsystem was expecting the transaction counter to not change because there hadn't been any real transactions. And the fix of this was to simplify the rollback, so that rollback will not defer things, it will immediately run whatever purge would do. So this would result in smaller purge lag and simpler rollback of transactions and simpler logic for transaction commit. We have, speaking of deferring things, undo lock pages are not freed immediately. There is this cached undo lock state purpose of that is to allow the next transaction to reuse the same page. If you have a lot of small transactions, they can reuse the same undo log page, and then when the purge removes the last, processes the last of these transactions, then it can finally free that page. This will give quite a bit of performance benefit, because we don't have to wait for the tablespace latch for the page allocation and so on. Then there are some changes that improve the performance with temporary tables. Let's see, I got some extra. Okay. Well, you can read the slide. I guess I'm running out of time soon. But maybe the last one is worth mentioning. In the upcoming 11.3 release, we have a new configuration parameter, or actually a settable variable. You can request the temporary tablespace to be truncated in MariaDB while the server is running. Then something that I have been working on recently, still working on it, is reducing this purge lag. There were several problems found by running a benchmark. One of them was pretty kind of a surprise, which I got after running the off CPU time tool. It would show the weights inside the threads, and I found out that there was a rollback segment latch that the purge coordinator task was acquiring and releasing many times instead of just doing it once per processed record. And I think that this could have been contributing to more purge lag compared to older releases, because other user transactions could grab this rollback segment latch for starting or committing a user transaction, and that would block the purge coordinator from processing the records. Now the purge coordinator is a bit more arrogant or selfish, and it will hold this latch a bit more, and then it will be able to proceed with processing the records. And then there was another thing. I noticed that table lookups are taking quite a bit of time. Basically, almost for every undo log record, we would look up the table ID in the MariaDB dictionary cache and get the table for that table ID. And this was costing a lot of CPU and lots of weights. So what I did, it hasn't been finished yet. I need to fix some things regarding to DDL, but what I did was that the purge coordinator will look up each table ID just once and then keep the reference to the table for the whole purge batch. And the purge worker threads will process a readily looked up table. And then one thing we are doing, we were copying undo log records from the undo log pages in the buffer pool. Just because somebody thought that you must not access records when the page is not, when you are not holding a page latch. But I think that by design, how the undo log subsystem works, we don't actually have to lock the undo log pages. Only we need to hold a buffer fix on the pages. Because if we are doing a rollback, we are the thread that owns the transaction. Nobody else can write our undo log. We are owning the undo log pages. So we can just hold a buffer fix when doing rollback. And similar in purge, the purge coordinator owns all the records that are going to be purged. It is the one who is going to free them. So we don't have to hold any latch on the page, and we don't need to copy anything. We just keep a pointer to the pages. Pages cannot be removed from the buffer pool because we are holding a buffer fix, and that should be enough. And then there was some funny thing. We had implemented some throttling so that the purge wouldn't cause drop of throughput during normal workload, but actually this throttling itself could cause the purge lag. So maybe in this case the cure was worse than the disease. And I think that any type of throttling, you should be very careful when thinking about introducing any throttling. Like previously we have this InnoDB thread concurrency or whatever these parameters used to be, limiting the number of threads that can be inside InnoDB. It's just a workaround. It's better to fix the actual bottleneck, and then you get a simpler design and maybe better performance. And this was actually something that I didn't find by off CPU time, because this shutdown thing. Well, it was that the shutdown was using this throttling was happening in the wrong way, and shutdown was thinking, oh, the system is overloaded, I must reduce the number of threads that I can use. And in the end it was using just one thread for purging the history instead of the 32 threads that was supposed to. So in 10.6 the slow shutdown is slower than it's supposed to be, and in the next release, hopefully, if all these changes are implemented, it will be fast again. Then some future work regarding the secondary index pages. I think that we should introduce a per record transaction ID. And I believe that for purge, then we wouldn't have to look up the primary key for each secondary index. We could just get the transaction ID from the record and then be done with that. But this is something that requires a file format change, and that's why I have been reluctant to do it. Okay, thank you. That's the end of my talk. Are there any questions?
Can you show the last page again?
If I want to say that, you said transaction ID into secondary index record. Will it affect the size, right?
Yes, adding the record to the adding the transaction ID to the record will, of course, increase the size. But in that MW you can read that there is optimization. If all the records in that page are old, then we will not use the space. It will be similar to the current format. Or only for the so-called active records, it would use more space.
So what are you actually doing with the slow case? I mean, are you going to add the log to each secondary key, or to the primary record, or where? I don't understand.
This would be better explained in my previous talk 1 year ago. So to avoid having to go to the cluster index for the primary key record to find which version of the primary key record corresponds to this secondary index record, we would have the transaction ID directly in the secondary index record.
Okay, so you add the transaction ID.
Yeah, so basically it's adding some redundant information.
I have it in the area, so then it was not clear from that sentence.
Okay.
Questions from Jean-Francois. Sorry, questions from the Zulu. Is the shrink of the InnoDB log space on startup? And if so, does it delay the startup of the server?
Shrinking the InnoDB system table space on startup, I think the question was about that, because normal unlocked table spaces can be truncated during the normal operation. I don't think there is much overhead, or I don't think it's very slow to shrink the system table space on startup. It basically goes through a linked list of pages, and those are every InnoDB page size pages. So if you have 16K page size, 16K times 16K bytes, that's 256 megabytes maybe. Every 265 megabytes you have a page that needs to be accessed. So it's not that much. We are not going to defragment or move anything around. We are basically just traversing those lists, checking what is the latest allocated page, and then we are trimming these lists so that no page after the new end of the table space is there. So I don't think it will be much overhead. Maybe, can't say, depending of course on your storage, but let's say at most a few seconds.
Okay. Yep.
But only if there is having massive work.
Well, I can't say for sure. Maybe somebody should test it on production or maybe staging to see how it is in their case.
A couple more questions on the secondary index lookups when you're actually purging, is the amount of effort that MariaDB expends in that observable in any counter kind of way?
Yes, we have some global counter on page accesses. I don't remember if there is any counter in the purge subsystem itself. Maybe not, but it could be a good idea to add a counter for that.
Okay, cool.
Okay, then I guess we are finishing in time. So thank you for your attention, and have a nice next talk.
So when Morozov gives you signal, you can present Peter. And we already established that Peter can see and hear us.
Okay, now for an exciting overview of the differences between MySQL and MariaDB, specifically MySQL 8 and MariaDB 10.11. And that's the first for me to present Peter Zaitsev, not for this type of presentation, but where the first one where the comparison point exactly is 10.11. I've seen these presentations, earlier versions, a couple of times, and I'm really looking forward to being able to, or for Peter to be able to share this overview once again. So please go ahead, Peter.
Okay, well, thanks, Guy. And for me, it's indeed very interesting to have the ability to give a series of this presentation for quite a few years, right? Because that allows really to show a process, right? Progress, right? And I think it's very interesting, at least for me personally, to see how things are changing release after release, year after year, right? And not only in the code base, but I think in the ecosystem as a whole. And then thank you for placing the laptop so I can see the all the crowd. I think that is very cool. Oh, hey, some people waving. That's fun, fantastic govern you have, and I am so much looking forward for once, sometime not having a conflict in my calendar, so I can join one of those events. in person. Okay, well, with that out of the way, let me get started. And you know what? One thing before going in the comparison of specific versions, right? I think what this is a very interesting times in MariaDB ecosystem, right? Which I think is would be interesting to acknowledge, right? On one extent, we see significant amount of uncertainty, right? I think is especially as it goes to their MariaDB, corporation. You guys may heard about some, warnings from a stock exchange. There is this kind of, buyout proposal, right? Which I know is getting a lot of questions in this regard. Hey guys, what is exactly going to happen, right? That doesn't mean the outcome is going to be negative, but that means there is, of course, increased number of uncertainty in the ecosystem, right? And obviously, I think some of you guys have still heard the plans of Azure to retire MariaDB, right? And I particularly didn't quite like in that announcement their desire to say, hey guys, move to MySQL. There, I think it would be fair to also to highlight another alternative, well, because you can run MariaDB as any open source database in any cloud. You just have to do it yourself. And I think for many, especially those who love MariaDB but have to run on Azure, that may be more feasible option than to migrate to MySQL. Now, I think there are also some other wonderful developments, right? One is AWS has joined as a diamond sponsor, right? And I think it should be euros, right, not dollars, right? As I understand from the board, which is a very significant contribution, and I think it's great to show in the path what MariaDB Foundation and MariaDB project as a whole can be more independent on their fate of their MariaDB corporation or MariaDB PLC. And what is also very interesting here is as I looked at the board minutes, right, which is another piece I like to review before doing those presentation, I can see this is a very great energy and at the board levels. And I think it's also very good quality of board minutes and a great transparency, right? Which actually you sometimes don't see in some of those other foundations, right? Where you can see, well, just filing some minutes to sort of like show what we are transparent. But I think here we can see actually meaningful, discussions which are available to the public, right? And I think that continues being building trust with MariaDB ecosystem. Here are some highlights which I found quite interesting, right? Like one, I think this is an interesting suggestion of increased comparability for MariaDB with MySQL. And I think that is especially important, right, as we will talk later, what we can see increasing focus from Oracle on doing things as a cloud only, right? A lot of cool innovation from in the MySQL side, unfortunately, has become cloud only. And specifically, the second suggestion here is very relevant, right? Is making MariaDB support this kind of a new fantastic movement with AI, especially generative AI, right? And this kind of vector storage, right? Where you can see a lot of databases has added some support of vector search, and with MariaDB and MySQL has been has not been ahead, right, in this development, right? And I think Oracle did some stuff, right, in cloud only version, but again, who cares about that? And what I also was very glad to see is this. I would say see what MariaDB Foundation board sees their relationship with MariaDB PLC getting better with a new CEO and the management team. I think that is again can be fantastic for whole MariaDB community because, well, let's face it, right? MariaDB PLC still is a very important player in the ecosystem as it should be. Okay, with that out of the way, let's talk about the conventional content of a presentation and really talk about the MySQL and MariaDB there. They are and what is happening. So, from development model standpoint, you folks, many of you probably have seen this presentation before, right? We don't see a lot of changes in this case, right? I think if you look in this case overall, what MariaDB does the truly development in the open. I think, as you can also see from this, ServerFest and MariaDB on conference, right, where you get external contributors are invited and discuss, hey, what is going to happen. MySQL Oracle doesn't do such a thing, right? At least as open stuff, they have some meetings with some of the key customers, but there is not as much community involvement. Contributions are accepted in the Oracle, but I don't think they are encouraged in the same way. And also this approach at Oracle, where we have sort of like a dropship open source, and every few months we just boom see, oh, that Oracle released X, right? That actually discourages contribution because there is a chance that you are working on something, right, and Oracle working in that in a parallel, but you just don't really know about it, right? And then boom, 3 months later they release something what you also were thinking to work about, right, to work with, which is not fantastic. Now, what is interesting also with MySQL is what for years MySQL has not been really something significant in the Oracle ecosystem, right? You would see Larry did not talk about MySQL a lot, and I think that was actually good for MySQL because they were able to do things they think they are appropriate, right? Well, in the recent years, where MySQL is out there in Larry's mind, but only as a cloud database and only specifically as a cloud-only heatwave technology, which guess what? Heatwave supposed to make melt a snowflake, right? If you guys don't get the idea where the name comes from, right? And a lot of that innovation is a cloud only and has nothing to do with their open source MySQL, rather than kind of latching on the name and community and success, right? There a lot of stuff is just going from AI support, right, and supporting various like new vector extensions, generative AI. Again, MySQL is also implementing that as a cloud only solutions, which is unfortunate. Wants and sends, right? And what I also heard Oracle folks, right, using some lame excuses in this regard, stating, well, we do that because the various ML extensions, you need more than one system to run on it. Well, guess what, right? There are a lot of people running MySQL or MariaDB, right, on many hundreds and thousands of nodes, right? It's not really a problem. Okay. Now let's maybe again review what we are talking about in case of MariaDB the ecosystem, right? There are a couple of the big players in this case. One is MariaDB Foundation, right, which is as we all know, is a non-profit focused on MariaDB, right? And then there are also MariaDB PLC, which is still doing a lot of development in MariaDB, right? And it builds a lot of proprietary solution software and SaaS, right, in that space. And as I mentioned, relationships can be, complicated, right? As you can even see acknowledged in their board meetings. Now, what is interesting in this case is what at this point, MariaDB Foundation is mainly responsible for MariaDB Server. Well, if you think about the whole MariaDB ecosystems, there are many like other bits and pieces, connectors, so proxy as a max scale and whatever, right? Which are owned, managed by MariaDB PLC with variety of licenses, some open source, some of source available license as BSL, right? And though there is a growing amount of contribution coming from other parties, there's still majority of roadmap development done by MariaDB PLC last time I've seen. I think what is also interesting in this case, right, is if you think about the board members, right, or the governance of MariaDB Foundation, you will find a lot of faces which are very well known and respected in the open source and open source database ecosystem, and which is kind of very different from MariaDB PLC, where it's typically very different kind of crowd. One of my pet peeves, right, which I have highlighted from that kind of complicated relationship is if you are going and say, hey, you know what, I love MariaDB, I love open source, I'm using the stuff of MariaDB Foundation provides, you download stuff from mariadb.org, and then you kind of get redirected maybe unknowingly to MariaDB corporation, right, and encouraged to provide essentially the sales lead so you can be contacted by salespeople, right? I think that often is kind of confusing, right? And you can even see here, say, hey, yes, you know what, you are giving your information to MariaDB Corporation, but then it's may share that information with MariaDB Foundation. Why is that when I am, as a user, choosing to engage with MariaDB Foundation, actually? Well, what I think is interesting in this case, to quote board meetings, in this case, I very much appreciate what probably, me kind of poking the bear about that, right? Consistently every year, right? Being noticed, right? And I see that question brought up in a broad meetings. So, thank you guys for whoever made sure it was discussed, right? And again, right, in this case, I understand why that situation has to be done, right? Because, well, we all live in a real world, right? And the developers and other folks, needs to be paid where they are working for, for-profit entity, for non-profit, right? So there is a need to find a balance here, all right? And it is just my hope, right, as MariaDB Foundation has more support from a different different organizations, it has more options in this regard. Okay, let's now talk about the open source, right? Of course, when we talk about open source those days, right, it's very interesting, right? As typically we speak about the open source, and then we mean kind of something else, right? It's kind of maybe open core, it's maybe source available, it's maybe kind of open source is like, cloud only stuff, which I don't think we even have like a good name for that, right? But I think it's very good to see always like, okay, what is exactly open source, which I can as a user use without requiring any vendor relationship, and which is not, right? In MySQL, it is an open core model now with, let's say, some cloud only additions to that, but then there is what you can see, the whole component exists in that open source version, right? There is MySQL in a DB cluster, including some sort of proxy, and was not, which is in an open source the case. In MariaDB ecosystem, the server is open source, connections are open source, right? There are some other pieces as MariaDB Max Scale, which was open source, but which is BSL now. There are also, I think, have been some other hesitation to open source some what probably is considered higher value stuff, right? Like expand storage engine, which was which came from a Clastrix acquisition. From a position standpoint, if you think about MySQL, it's also quite clear. The MySQL Enterprise is a superset of a MySQL community, right? So there is nothing you use in MySQL community which is not going to work in a MySQL Enterprise, right? And you also have like a very much aligned release schedule, because that's obviously done by the same group, right? In MariaDB case, if you think about enterprise server, it is kind of more of an extended subset of community, right? I would compare that idea probably more to Red Hat's idea, right? When you can say, hey guys, we had this Fedora, which is allowed to innovate and maybe put some of their earlier stage ideas, and then we pick and curate and have only some of them available in our enterprise enterprise grade version. Now, one thing, this is like I see that as a very important area, right? Approach to their cloud native. Now, one thing what is interesting in Kubernetes and databases right now, right, is it is really growing pretty fast, right? If you look at a cloud native community like surveys, you can see what the amount of database deployments on Kubernetes has increased by 50% over last year, right? So yes, Kubernetes was not designed to run databases, and it was extremely bad for running databases and stateful applications for many years, but it is now graduated where it is quite able to do so, right? And I think that is what we see increased interest in that space from people, especially looking to achieve more of that, cloud independence, right? Because obviously, if you, locked into something like Azure managed services, is you will have to, pay the significant surcharges which have been increased, and then they are going to attempt to define your roadmap, right? Like in this case, say, hey guys, you know what? We decided we're not doing that anymore. So you have to, go technology you like, right? And that is where I think it's very important to have support for Kubernetes, right? I would say like on par with Linux as a deployment target. And what I see often is kind of an interesting, right? It's often another world, right? A lot of old timers, right, which got used to running, MySQL, MariaDB, other database on Linux. Let's say, oh my gosh, Kubernetes isn't complicated. It's kind of, stupid, right? I don't want to touch that. But a lot of a new generation of folks, right, they are ready to do that. Well, anyway, if you look at the MySQL ecosystem, which they implemented as a GA, the MySQL operator, I wouldn't say it is kind of particularly good. And I think it's more, as a checklist feature for them, because of course their focus is, hey, if you want to run MySQL in the cloud, guess what? You go and run managed solution, and it's even better because it has a heat wave, right? But I think that is a good opportunity for MariaDB to provide a good alternative out there, making sure that Kubernetes is seen as a first-class deployment platform, right? And there is a finally, well, MariaDB operator, right? I think it's has been in development quite a long time, and I'm looking forward to see where we see finally, you know, GA release of that technology. Well, database as a service, right? I think it's interesting what obviously MySQL and MariaDB community versions are available at a variety of clouds. What I think in this case, though, you can see what a lot of second-tier clouds, which are you know, offering the database as a service for those days as well, often may just offer, well, you know, MySQL Postgres, right? Not like a MariaDB Postgres, right? At this point, right? And then there are also so far, if you look at what Amazon has done, for example, for their improved Aurora version, right? It's based on MariaDB. Oh, MySQL rather than MariaDB. In both cases for MariaDB Corporation, MariaDB PLC, sorry, just always going back to that new name, because MariaDB Foundation, MariaDB Corporation, right? It's almost sounds like poetry, right? And then MariaDB PLC is kind of, you know, break the flow. Anyway, and as I mentioned, if you look at Oracle, there is a lot of push for heatwave. It is interesting approach to their analytics, of course, right? I think both MariaDB and MySQL, they understood this market. You can think about HTAP, or saying, hey, you know, we want to have a single system which we can use for analytics and maybe transactional databases, right? And MariaDB has a column store solution for that, which both exist in open source, right? As well as MySQL has heatwave. Now, maybe I'm kind of wrong here looking at the ecosystem from this standpoint, but I have seen a lot more column store interest and usage a few years back, and I think now you also have a lot of sort of purpose-built, you know, column store database technologies, which of course have a lot more flexibility, right? How they design things, they don't have to kind of, you know, try to support everything, you know, MySQL does, or have some other restrictions which have enabled them to provide more performance. What is the focus for those technologies? Well, if you look at MariaDB, right, I think initial focus was competing with MySQL on features, and MariaDB really initially released the first version of a lot of cool stuff, but then those features were also implemented by Oracle, right? And that is kind of not really a very good sustainable advantage. I think more recently, I think there was a lot of cool focus which is either on compatibility with proprietary database to EID migration, as well as really thinking about their needs of both DBAs as well as developers, right? I think this is what MariaDB can prize themselves, right? Being close, right, to the various other parties, right? Like, for example, MariaDB, I think, does a lot more work and a lot of better work with various Linux distributions, right? Like aligning releases with, you know, major cycle and other distributions, which MySQL does not really do. Now, in terms of MySQL, there was always this kind of question to what extent MySQL is looking to implement some of the advanced Oracle features. And obviously, obviously they don't, right? And I think there's still this kind of question going around to what extent it is because MySQL customers, they just really approach databases in a different way, and maybe look on database being more simple, or to what extent that is because of a restriction the MySQL team has operating in the Oracle structure, right? And what the corporate overlords, right, may require them to do or not to do. If you look at architecture approach, I think that is also very interesting, and particularly I see that coming to head right now, right, where we can see their MySQL 5.7, which is a version which is based on the older kind of architecture, goes end of life, right? And now you have to migrate to MySQL 8 even if you don't want it, right? And we see what because of a very significant changes, even though it has been out for MySQL 8 has been out for many years now, many companies haven't migrated and have a hard time migrating that, right? You guys may have seen Amazon extending MySQL 5.7 lifetime, right, because of customer demands, right? And also at Percon we provide extended post end of life MySQL support because there's a huge customer demand for that, right? But this is all saying to that what MySQL took a bet on a very big refactor in a MySQL 8, and that obviously also has been hard for some customers to do migrations. One thing I also want to highlight here is I think the certain decisions in MySQL has been kind of a little bit kind of disconnected from reality, academic and more than a practical, which have implemented some needless complexity, right? Sometimes you read about certain things implemented, it's like, well, needlessly complicated. And I know what that is a case where many MariaDB users appreciate the more practical approach in this regard. Now, another difference I think which we have seen is MySQL is super focused on InnoDB storage engine, right? I think it's increasingly the InnoDB. We don't even hear a lot about the MySQL cluster slash NDB those days, right? The product exists, but it's kind of we don't hear much about it. Where MariaDB has been supporting multiple storage engine to much more extent than MySQL, though of course I think still majority of data store in MariaDB probably uses InnoDB as a storage engine. So let's look at release frequency. I think this is kind of also very interesting. What we can see, in terms of MariaDB, there is a lot of releases coming up, especially recently, right? We can see this new approach where MariaDB produces both LTS releases every couple of years, and then more of your short-term support releases in between, right? Kind of to balance both desire some developers to get access to the new features faster, and then desire for stability for other maybe more enterprise usage. What is interesting in this case is with MySQL took another bet, right? Another big change of MySQL 8, where before that you would have sort of bug fix only in minor releases, where in MySQL 8 you see every release comes with new features and also bug fixes. MySQL 8.0.34 right, for example, is a very, very different in terms of what features it has compared to their first 8.0 releases, right? But with that, of course, there is more risk in upgrading, and which is especially the problematic because there is no downgrade support in MySQL 8, right? So if you are upgraded to MySQL 8.0.34 and things don't work, you cannot just, replace the binaries with 8.0.33, right, and fix it. Well, chances are your data will be, converted to enable some new features, and their 8.0.33 would not be able to just work with that data, right? I mean, and I know, like, for a lot of people operating MySQL, that is not appreciated. What is interesting is Oracle also, I think, heard this feedback, and they have been moving to something which is similar to MariaDB models, where they have now what's called innovation releases, right, which are expected to be released, every few months, and which will be, just only supporting the last innovation release, if you will, and at the same time releasing those sort of like a normal long-term support releases, right, which will don't have as big change between a stable version. So but we're still to see how that actually materialize and get executed, because we don't, it's so new. So yeah, that is their the release philosophy of what you have, and it's also have some links if you want to research more about what MariaDB and MySQL are doing. Okay, with that and a little time we have left, let's look at some specifics, right? So if you look in this case, MySQL has been actually given a lot of focus from the client protocol to have X protocol introduced. I don't think it has like a super tremendous uptick so far. I still see a lot of people using the older protocol, and I think this is again where MariaDB took kind of more iterative approach of extending classic MySQL protocol, like for example, extensions for progress reporting, right? Rather than saying, hey, let's go ahead and scrap and redesign. Right. I think what is interesting in this case, like thinking about that, I think what happened also in MySQL is this interesting thing about, not invented here, but in the side of in the scope of initial company, right? I think what is in MySQL, then Oracle acquired MySQL, the original MySQL development team was merged also with people from some other groups in Oracle, right, which have been, new guys with new perspectives, right? And in many cases, I think they wanted to challenge, right, and make their own mark in terms of redoing that kind of older MySQL decisions, where I think MariaDB with Monty and everything could keep much more of that, legacy, right? And I'm using the word legacy in a good sense in this case. If you look in terms of like an interface support besides SQL, MySQL have been implemented the document store. And I think for a few years, there was a lot of push of that. I was using MySQL as a document database. I don't see that that particularly successful. The MariaDB server has only SQL and handler socket support, where of course vast majority is SQL. Though I've seen some support in MySQL for supporting MongoDB protocol, right? Though I haven't seen a lot recently about that being for actually used a lot in community. There has been a lot of focus on JSON support for both databases, and that is different. Where MySQL took approach, hey, we are going to implement the JSON data types. There, MariaDB said, well, you know what, actually JSON is text, while we just, don't store it as text and just implement the freaking fast parser. So parsing that JSON is not a problem. I think for many releases, you would see MySQL actually being significantly ahead of MariaDB in JSON support. But I think in the recent releases, that gap has been becoming smaller and smaller. One, I think, gap which still remains is the support for JSON shortcuts. Right. And I think in general, you think about the, usability. I think for modern developer, it is not a question whether you can do it. Right, it's a question whether it is convenient to do things, and if they're not convenient, even if they're possible, right, they wouldn't be used. The MySQL also took a different path when it comes to their replication, right? Where both MySQL and MariaDB has GTID support those days. They're very different, and their MariaDB used for sort of like clustering support, Galera replication. MySQL has, implemented like a similar but entirely different solution from scratch called MySQL group replication. In terms of SQL standards and comparability, I think that is something where MariaDB put a lot of work and excels, right? It doesn't really come to mind anything significant what MySQL can do, what MariaDB doesn't. But MariaDB does, quite a lot of things, and it's not just about comparability of Oracle, but it is also, I think, competing with databases like Postgres, right? For example, if you think about the sequence support I mentioned here, well, guess what? Like a lot of Oracle folks, they use and love sequence support, right? Where MySQL has been, just given a very limited set of features in this case with after increment. Security is another thing which has diverged very significantly, right? I think if you look at that, until 10, 15 years ago, right, I don't think security was at the same level of importance as it has become in the recent years, right? If and because of that, MySQL and MariaDB has independently had to level up security, right? And they took a very different approaches in this case. Now, some of the significant, I think, cool thing that I like in the MySQL 8 changes is their dual password, reloading the TLS content without restart, dynamic privileges, and their password policies. Optimizer is another thing, right? MySQL 8 implemented a lot of optimizer changes, and now in MariaDB, especially if you go to MariaDB 11, again, we have very significant changes in the optimizer, right? And as somebody who is passionate about the database performance, right, that is something I always get people hate to think, pay special attention, because from a database standpoint, you should not be thinking only, oh, wherever the same query will work on both database systems. The performance also matters, right? If there is a 10-time difference in performance, well, guess what? It's maybe totally impractical, right, for you to use one or another data technology, right? And optimizer differences can produce changes which are even larger than that. MariaDB comparability with MySQL, right? These are, I think, some of their newer additions to MariaDB with MySQL, and I think MariaDB takes here a pretty practical approach, right, in terms of seeing what features are the most used, and by porting those rather than saying, hey guys, we're just going to copy everything, right? Like we are going to also implement doc store in MariaDB, even though there may not be as much user demand for that feature. Here are some of the pretty cool things which I particularly like about the recent MariaDB ideas, right? I don't understand, like, for example, why for so many years MySQL just doesn't implement UUID data type, right? People love UUIDs, right? And there is a way to store them and process them more efficiently, right? Never came in existence, even though JSON data type, which is tremendously more complicated, was implemented. Log-free replication is also very important, right? Again, because if you just even if you have like online alter table, right, having delay for your secondaries, right, of many hours to implement that data change is can be very problematic. And I also like a grant to public feature, which allows a lot needs a security implementation in many cases. Well, another topic what I want to touch on in this case, and it's kind of like a newer and recent addition of a slide, which I was kind of thinking a lot about what kind of communities we need to be thinking about to make a project successful, right? And I think while we talk about one community, it's actually probably 3 communities you can think about, right? And I especially look at that, I think, like if you compare what they have at MySQL and MariaDB to something like Postgres. One, of course, it's the user community, right? These are people who use your software, right? And I think especially for databases, guess what, right? Relatively few people will have the skills to write the code in a database kernel. But there are a lot of people using a database where find it awesome. They tell their friends about that. They maybe write an article, talk about the conferences and so on and so forth, right? And I think from a user standpoint, we can see MySQL and MariaDB both have a very loyal communities, right? Now, if you think about the contributor community, right, that is I think MariaDB has been a lot more successful building relationship, right? Because I think in terms of MariaDB, their community of contributors involved in Maria's success was very important. Therefore, Oracle, it was kind of, well, you know what, we don't want people looking to contribute to feel bad, right? So we'll accept contributions, right? But if there would not be much contributions from a community to MySQL, I don't think Oracle would shed a lot of tears. What I think is another one which is very important here, though, is the vendor communities, right? These are the people saying, hey, okay, who is going to provide like solutions, right? If I am the enterprise with whom I can have a commercial relationship, right, in this regard. And that is what gives a customer's choice, right? And avoids lock-in. And that is what, in a practical sense, a lot of open source is about. You can see in this case, I think, very interesting how PostgreSQL does it. Why there is a PostgreSQL event happening every week somewhere? Well, it's probably because some vendors are participating in that, because they can spend a lot more time and effort of organizing those events, right, compared to just other kinds of community, right? And compare that on the other side. I think, like, I always like to compare PostgreSQL to MongoDB, which just which are focused on we want to have it all mentality, right, and not really encourage any vendor community to be creative, right? And why I'm talking about this case, right? Because in my addition, outside of cloud native, I mentioned, right, that is also something which is an opportunity for MariaDB to encourage, right? To encourage more vendors existing in variety of in different places in the world, right, which help with can companies to provide some commercial solution in the MariaDB space. Okay, well, and that's all I have, and I think I still have a few minutes for questions.
additions and good overview of all of this, and I can tell you that we are working on some of the stuff that you mentioned, so stay tuned. But let's see, what are the audience comments and questions?
Did I hear Monty was saying Kubernetes is for losers?
Hi, Peter. I'm glad you mentioned replication, something from this field, dear to my heart. But do you have any impression about parallel replication to compare MySQL with SAS? What can you say if you try?
Yeah, well, yeah, thanks. Look, I think that is a very good point, right? Look, and I think that's one of the things where the MariaDB and MySQL has a different approaches, right, in this case. Now, I haven't really run a lot of benchmarks myself recently, right? I mean, it's kind of interesting as with many of those engineering approach, right? You talk to, MariaDB folks, you talk about MySQL folks, right? And they always speak, hey, our solution is better for one reason or another, right? But I can't really say much more.
Eric.
Thank you, Peter. I was extremely appreciative of your comment that there's nuance, that it's not always about what developers can do things, it's about whether or not it's convenient or easy to do things. And that made me think that you probably have some ideas of things that you wish were easier in both databases or either database. And what are some of the things that are irritating or kind of itchy that you would like to see if we could make more convenient?
Yes, well, I think in this case, I think about this one thing I mentioned. I think this a Kubernetes support, right? And why I'm talking about this, right? Because if you think about the old times, you remember, I mean, from even my times in MySQL, what is now 20 years ago, right? This kind of rule of 15 minutes, right? Hey, I get my working database in 15 minutes, right? And I run that on it, but potentially can think about the, server, which is I'm running for, right? Now, if you look at the, current environment as we have, if you think about even moderate production, just having a single server, it doesn't work, right? And that is where, how do I set up a database cluster? It's not a 15 minutes anymore, right? And saying, hey, how can we get that so we can have in an open source convenience similar to what I'm getting in the RDSs of this world and so on and so forth, right? Because that is important, right? I think you also need to appreciate what DBAs are dying breed, right? I mean, in reality, in many smaller organizations, there are no more DBAs, right? You think about the developers, right, which expect we can just deploy the database in a couple of clicks and that thing will run itself. That is what you got to give them to, right? And it's not only that 15 minutes, but it's also how can you think about the database, tuning itself, right? I think that's kind of stuff about what both MySQL and MariaDB require a lot of tuning, right? And that's why solutions like auto-tune exist, right? In this case, and they are able to charge something like $500 per node for actually tuning parameters, right, with a database, right? Why? I mean, I think a lot of those things can be done by databases.
Okay. Yeah. So if you could go back to your sad face page.
Which one you want?
Your sad face page in the beginning, I think third page or something like that.
Oh, yes. Yeah. Page, okay. Let's go. Third page. Okay.
So there's one thing that is missing there that I'm much more unhappy.
This one or this?
The unhappy face.
Okay.
Yes. So the one thing that you're missing there, I need to fix that because MariaDB has not been present on Percona's different conferences, and we definitely should be there. And it would be great if we could have a much closer relationship regarding that.
Yeah, well, absolutely. Like I think that that would be great, right? And I think there may be some opportunities to work better and work closely in this regard.
So I think we have time for one more comment, and that's a comment that I have asked Martin to say a couple of things or something about Kubernetes, perhaps.
Yeah, first of all, thank you for mentioning, well, I'm the maintainer of MariaDB operator. So first of all, thank you for mentioning me. As you say, we are in development, but yeah, we are quite getting some traction, so it's always good to be mentioned there. So my question is, what do you think it's missing in the Kubernetes ecosystem for, encouraging these folks that are still running VMs, or maybe, just installing RPM packages to actually move to Kubernetes? What do you think we are missing? What we could do better from the Kubernetes side?
Well, in my opinion, right, my main comment was in this case in saying, hey, it's important to release GA, right? Because in reality, at least in my experience, many people are just not going to spend time on that, right? For example, in terms of Percona operators, look, some serious people which could provide wonderful feedback just would not touch them until they're GA. Right, so I think that is the first thing I would get in this case. Like, hey, maybe it's kind of a limited feature set, maybe limited application, but it's get that GA done, right? And I think a second thing goes back to that usability, right? How close you can get for that, Kubernetes is getting used to, let's say, some self-running database, and you can, obviously have a lot more, things those days, including, hey, we can automatically scale the database nodes, right? In this case, Kubernetes allows that. That's one of the wonderful things, right? Or in terms of storage, new storage interfaces, you can actually even give users by default, hey, you start with the volume, which is, small because your database is small, and you just never run out of space, right? Which is one of the big problems with databases, right? Because the operators, especially if you run in the cloud, right, is known smart enough to extend the underlying volumes, right? And there is a container storage interface integrations which allow that, right? I think this is I think what is important, I think this is it, right? You need to really think about what new things, what this Kubernetes platforms allows you, right? And leverage that. In addition, what your kind of conventional fixed set of Linux VMs, right, with bare metal would give you.
Excellent. So on that forward-looking note for the newer developers, I think it's time to say thank you to Peter Zaitsev. Thanks, Peter.
Okay, thank you. Good to meet you guys.
Don't miss the next talk.
Don't miss the next talk. And the next talk, it's by somebody called Monty, I think. So can Monty come forward and tell us what is this catalog thing?
Where do we have the slides? Are the slides in the back?
Yeah.
Don't talk till Marozov waves and stand between the chairs.
Where? Here.
Exactly. So this is your space between these chairs, and up and down arrows on your feet.
Okay. Very small screen. Okay, we're ready. So it's always good to end with something new, and we still have people talking there. Okay. So I was recently at a CloudFest, and talked with some SaaS providers of what could we do better with MariaDB. And sooner or later, when you talk about having tenants on databases, you had a problem with tenants that are noisy, that causes problems for those. And for to be able to find out who they are, you need better tools, you need for monitoring, finding those, and being able to move them from one hardware to another one. And so that was kind of the start of everything. The other problem is also that Hostess has that, how can you put more and more tenants on the same hardware, especially with the noisy neighbors that you can monitor. What the easiest solution is just to put them on different virtual machines, Kubernetes, or whatever. But the problem is that the typical hardware nowadays is about 190 gig, and when you have 1 gig of memory plus overhead, you usually can only put about 100 users on a specific hardware. And how to avoid that is to have one server and one database per tenant, but then you have the problem is that you can monitor them because MariaDB doesn't allow you monitoring on the database level, and you also have lots of other issues to it. So basically the normal model is one physical machine and one virtual machine per customer or tenant, or you basically have one database. So catalogs will change that basically that on top of the database you will have catalogs as one extra directory on top. So it's basically exactly the same disk layout as we had before, except we had one directory on top. And the server will be able to run either in the normal configuration or not. You automatically notice that you have configured the catalogs, they will run with the underlying schema. So we are trying to provide the best of both worlds to be able to make it easier for users. So when you run with catalogs, a tenant will basically see something that looks exactly like a normal MariaDB server. You have your own users, you have your own databases. You can have, according to what you have paid for to the vendor, you can have any number of databases, any numbers of users. You're not constrained by just the one user and the one database name that the SaaS provider has provided with you. And the catalogs, we still have a problem with the noisy neighbors, but because you can see the statistics per catalog and per the server, you can very easily find anybody who does something strange, uses CPU, uses lots of disk or anything. So, and it will be also very easy to move one tenant from one server for one catalog to another catalog of one, or for one server to their own server, and vice versa. And we will also be able to easier enforce quotas. And that will come in version 2. And I don't mind if you ask me questions at any time, because I'm the last person, there's nobody after me, I can talk forever.
We know it. So the types of quotas, is that like specifically like disk quotas or also?
We will start by adding quotas for temporary files, and then it will be extended. The first version is basically what you have now, but with much better statistics, and then I plan to work with lots of different SaaS vendors who are supporting this technology, and work with those and see what are the pain points and see how we can solve it. But at least we have a mechanism, because basically the catalog is internally almost like a container. So we can get all the statistics, and when you have that separately, it's also much easier to limit it. Much easier than anything we had before.
So I believe that in theory you can host probably 100 times more users on the same machine. It's still in development, and we are actually searching for in MariaDB through the MariaDB Foundation to sponsors for those who wants to see this happening, and also those who sponsor us will also get it backported to a special version, backported and kept up to date for 10.11. So this is now targeted for 11.4, and which means that in practice it will be out somewhere March stable next year, but looking at how MariaDB releases is getting into distributions, it probably will be by the end of next year until other SaaS vendors can actually get it. Those who work with us will get it basically 1 year, 1.5 years, maybe 2 years earlier to adopt their tools and test it out. And everybody who's part of the project will be, any issues that brought to our attention will be taken care of. So, so how to then use catalogs? So we'll add catalog options to all clients, and for all clients you have different ways to connect. You can connect just by putting catalog just before the database name. That will work for any client, all clients, new ones. This is something that Ionas, who's also supported the project, wanted, is that you can just specify a unique IP, and that will directly go to the server and directly log into a specific catalog. You can also do the same thing with port. And you'll be able to do nice things because the catalog structure is identical as you have on premise. So you can just take a MariaDB dump from your on-premise database, put it into a catalog, it will just work. You can take a catalog and take a dump and take it out. Tenant can only see the database objects and statistics that is just relevant for him. So you basically not, you can see that, for example, there are some global variables like number of syncs. So you can see something happening in the server, but you're basically contained without having to add any extra privileges. So it's much easier to set up. If you have this normal setup where you have one database per tenant, you have to set privileges. He can only do this and this and this. Catalogs, everything just works. You don't need to set up anything. And you can give them root access to as a super user for the catalogs. He still can't break it out from it. You can also do things that has never been able, nobody has been able to do in the, actually with any database before. You can set up, okay. Yeah, it's a Mac, Apple, what can you expect? Okay. You can set up a replication from an on-premise database inside a catalog. So you know suddenly SaaS providers can be a backup for something on-premise. You can be able to replicate from one catalog server to another server catalogs, or even from a catalog to an on-premise MariaDB. This will open new opportunities for SaaS providers to make money. And then we have the catalog root user. So we needed to have one user who can actually do all the things that normal users should not be able to do. For example, doing shutdown. So we have the default catalog is def. That actually is something that is already provided in the server and the client. It's kind of hidden, but it always existed. So I'm using that. The one who is super user of the def catalog, he can run any commands and even switch catalog to be able to do statistics in other catalogs, just to be able to see what people are using. So there's few commands that only he can do. And then setting up replication, we can't allow just any tenant to set up replication. That's because that may be overhead everything else. So that be a different service that the SaaS provider can do.
but it will be possible. So there are a few limitations. Each catalog will have a general log and a slow query log, so you can see exactly what just happened in that catalog. But there are some general errors from storage engine that can, for example, read error on a disk. That will be in a log outside. And then there are some tables that will only be in the def catalogs. Basically tables that are users doesn't normally have able to access, like replication, the timestamp tables, they don't change. Basic tables that are only needs to have one version. Or any other tables will be inside the catalog. So each catalog will have their own MySQL schema with all the normal MySQL schema tables and so on. So the current state, we have a documentation in the knowledge base with an overview. Then all open tasks are in the MDev with the added multi-tenancy catalogs to MariaDB. And we have about 20 open tasks that we are working on closing. Actually, the most hard ones, like for example making InnoDB catalog aware, that is already done. I will come to that soon. So to start with catalogs, you basically run MariaDB install DB like you would do when you instantiate a new server, but you have a new option minus catalogs, and then you just list the catalogs you want to do. You can also do that. That basically will create the databases, the def database, and all the catalogs. You can use the same command to just add new catalogs afterwards to a running server. And we only have one version, one binary. It will automatically work with catalogs or not. Internally, catalogs is the big change is that we have just every place where we create a file name, we just have to add the catalog's name in front of it. So the changes is all over the place, but they're still quite easy and easy to manage. So I think that this project will be reasonably stable from day one. So the specific catalogs commands that exist is use catalog, which only the root catalog user can do, but the normal user can still do that. You can always switch to your own catalog, because we use that in MySQL dump and everything else to have that work both for your installation and for making it easy to move between catalogs. Then create, drop, alter, show catalogs, show create catalog and so on. And basically we do exactly like we do with databases, that we have an opt file that gives you the default character sets and everything else. Each catalogs, by the way, will have their own config file. So you will have one global config file for everything, and then you can change variables for its catalogs in a separate config file.
But basically, from one catalog, I can see the list of all catalogs.
Only if you are the super root user. Basically, the SaaS provider.
Okay, cool.
So we are trying to contain it. So status commands. Normally, you have basically show global status and show status. So we added one show catalog status, so you can see what is happening in the current catalog. And then we added show server status, which is basically for the whole server. Normal users basically just use global status and catalog status. Which and I couldn't have global state to show everything, because that's how you already use for showing the status of the full server. So basically this makes things totally compatible for what users are used to. So the question, so what is already done? I would say that we are about the hard things are done. But there's still some tasks left, so I think there's 3-4 months of development yet. But and anybody can follow that in Jira. But basically, we have the most important clients done. Global status variables works. We have the previous tables per catalog. That's something it's done. We just need to put it in. And we also extended the connector so that we have an option that new C programs can use to directly connect to a catalog. If you don't want to use the catalog.database feature. So we have had the support for DLog events, backups, most important storage engines. Connect is not the most important one, but it has so many possibilities, so I wanted to see how easy it was to do. It took me basically a couple of days to do. Query cache, we actually can run the full MTR test with catalogs. But basically, that's our test suite. So everything works with catalogs. And there were about 300 tests that needs to be changed because it didn't expect that there will be a directory before the database directory, and there were lots of tests who went directly and expected files to be there when it wasn't. So I fixed everything, and this will be backported to earlier versions of MariaDB, so we can backport catalogs if we so want. And these are kind of the most important features that are not yet done. So the system variable per catalogs, I think and the Galera is the hardest one to do. But doesn't mean that they are infinitely hard. It will just take some weeks. I haven't looked at RocksDB. It may be easy, it may be not. And so the plan is get everything that works now to work. I still want to have temporary tables managed, which will be a new thing because there's lots of SaaS providers that ask me, so how can we restrict or see how much temporary tables or temporary files a tenant is using? So I will add that to the first version. And the next step, we will look at what can we do with constraining memory, constraining disk space, maybe using C groups. So that's something that I need to talk with SaaS providers to see exactly how we should do that. So that basically is, so I'm open for questions.
I have a kind of microphone so that we can. I have links. This sheet worked.
Okay, this is perhaps not a question for you, partially perhaps. I originally already kind of asked this question on somewhere, possibly on Jira, about the support, mainly for the network protocol and how you define a catalog. You mentioned earlier that if you connect, right now if you connect without the default database, you essentially are database-less, and you define it by saying use database. And if you are a super user, the root super user, you can define a catalog, if I understand correctly.
So the big change is that you can't connect without the catalog.
Okay.
So you have to use that as an option. So basically from the protocol point of view, the only difference is that there's a catalog in the first connections.
Yeah, it makes perfect sense. And I asked a question of, you showed the catalog of database syntax, and I agree that's the best probably way to do it. It's essentially a network address in some sense. And from what I then later discussed, I think it might have been on Jira or somewhere, where the Git commits, I think there is now an additional capability flag, if I am not mistaken.
Yeah, so
so it's fully opt-in on for the drivers, and I think that also means that all the existing drivers, all the existing installations would not be able to use this, right?
Anybody can use it by having a database that connects.
Okay, so it would be. So that's the kind of thing, and my question I think back then was, would this cause like conflicts or something? And I assume it's so rare. So I think this is mostly a question for the people who host databases. How often does somebody put a website name into their database? And how often do you have something user. I mean, how are my stupid worries actually?
No, but the thing is that that's solved because if you have a SaaS provider and using this,
yes.
So then you basically just.
No, that's good.
Okay, perfect.
So what you do is that you just configure your server and just say that you should tell the customer or tenant, use this hostname. Then he just connects, he doesn't need to do anything.
Okay, so you're able to connect to a catalog.
By just provided by connecting an IP or to a port.
And the server somehow understand that this connection from here
is
for this catalog.
Yes.
Okay.
So we have, I think I've covered every single possible case.
I mean, on the server side, does it understand that a connection coming to this interface on this port?
Yes.
Okay, that's perfect in that case. I think that kind of covers my question.
Yeah, I like to do it perfect from the start.
Well, I like that.
And as I said, this idea comes from Jonas. I wouldn't have come up with that myself. It's a good idea.
Question. Can you dynamically add ports and IP addresses to the server?
You maybe have to do that because you can add a new catalog at any time, and we need to detect that. We will read the config file, and then we notice that there's a new host IP we need to add, so we add that.
Monte, but does that mean that the server will always need a new IP address for each new catalog?
If you define it that way.
Okay.
But I mean, assuming that somebody forgets to do that, then you can still connect with that way, or that way, or that way.
I think my question was mainly, let's say PyMySQL, which is a connector. It exists. A lot of projects use it. It does not support any new capabilities if we don't do a pull request. If it's on the protocol level, I'm asking, can we just skip the whole protocol change and just start interpreting database names in a different way?
That's what you're doing.
Okay, that's perfect.
So this early case where it doesn't work if you have a database name with a dot in it.
Yeah. So and I would say that my worries are probably unwarranted, and this is what I would like to ask. In practice, I develop max scale. So
yeah, but consider that we are using dot as something between tables and
it's the natural way to. So is this more of a question for? How often do you see this?
An output from
basically, how often do you see you create a database that has a dot in the name for a tenant? Exactly.
Sometimes.
I saw somebody's website names their database. I mean, kind of makes sense, but that's the one case I've seen.
But usually when you are a tenant and you go to a SaaS provider and you want to use a shared server, you can't change. You have no control of the user or the database that you get. You will just get a random number or name or something. Probably you know better, but.
Well, at least for cPanel, people can choose the name of their database, and it lets them use whatever characters, and dot is one of them.
Do you get some sort of a URL connect to, or somehow, or?
Yeah, but people usually will connect over localhost.
Oh yeah.
Because it's usually just a local database. But people can make database names with dot, and they do exist out there. They're not common, but
that's good.
It's enough to like.
I can look at that.
Yeah. What I would like to see is that, or believe, is that this is a kind of a game changer for SaaS providers, and that will make MariaDB much more popular than before on that space. And thanks for that this project allows me to work closer with the SaaS providers we can do things that we couldn't do before, because we are not limited of what we are capable of doing. In this case, we are developers MariaDB. We are limited with the fact that we don't have all information of what is needed. So I hope that this project will help solve that too.
So I had a question. You were talking about how you expected to allow many more tenants per server. And that was one of your earlier slides. But then on the end, your very last slide, you have, here's all the things that are not yet implemented but coming up. Is your prediction about the number of tenants based on the stuff that is not yet implemented?
No, it will be most of the fact you will be able to find the nosy tenants. You will have much more information and control of each user. You can even put more limits per user, because now you have a config file. You can just say, this user has got some problems. He can't run queries that takes more than 2 seconds. That's actually what Alibaba is doing. They are putting really, really strict constraint for all the users. And that's the way how they limit it. But now you can do it, you just change the file, and then you put limits on those. That will help. But you are the experts. I mean, I just will be working with you to try to ensure that we can do that. And this is the best ways for doing that. And it also solves a lot of problems that even for normal users running things on premise, because one of the big problems is you have lots of applications running on the same server, but you have really hard time to see the statistics by user or by database. You don't have that. But now you can just put each application running in a catalog, and you can get all the information that you need for seeing what's happening.
Monty, I would say that this introduces the concept of ownership, which it doesn't have at all.
Yeah.
Because a user can own an entire container and be isolated from others.
Yeah. And this is kind of a cheap version of container, and why it's much better than having lots of containers is that there's lots of things that you want to share. You want to share the memory, the disk, and especially the MariaDB buffer pool. So you don't only have one copy of those. So with tempdir, I plan to have an option that you can put the tempdir under the catalog, so that you can easily just use any tool to see how much temporal space each catalog is using, but it will be a variable, so you can basically put it anywhere. So if you want to have, for example, a local file system for each catalog tenant, you can have that. Just a point. So but that all is things that will be more clear when people start testing. So I'm basically waiting for to give those to those who are sponsoring the project. We need to basically have the system variables catalog. Definitely we need to do not necessarily Galera, because I don't know how many people will run this in Galera at the beginning. But at least we need the system variables. So we are.
How do you suspect Galera will work?
Internally, it's basically just a path in front of the database name, and that's how I extended it. In a DB, as far as I know, everything is changed. So it may just work without any changes. It's only the catalogs. I don't know if there's a BSREP binary, how they will react to that. The file names are a little bit different. It may be trivial, so I plan to work with it.
But it will be like system-wide, and not per catalog, so as long as it's system-wide.
No, each table basically have a hidden path that is the catalog you are in. And each TSD has the catalog, so you can directly on TSD see this thread is running on this catalog. So basically what I'm adding, every time there is a path, I take the catalog and prefix that to the path that we are passing the storage engine. Storage engine works all by giving a path. So the only difference is that the path is longer,
Okay. So you've tested replication with this then?
We don't have, so what we're missing is some testing. So I've run everything with the def catalog. And I know that the catalog names is everywhere in replication. I haven't tested that we have two that we switch back and forth. I expect it actually will work. But that's something that we need to do at testing.
Yesterday it was said that in replication the master and the replicas need to commit the transactions in the same order. Am I correct that with catalogs this is not entirely true?
No, so we can have a different service, what is it called? Christian's not here. But so we basically have the group ID.
Domain ID?
Domain ID. So you can have a different domain ID per catalog, then you can run everything per parallel. So that's something when, as soon as I have fixed the system variables, Christian will get access to the tree so he can see how we can run those independent of each other.
But I think the idea is that replication is not something that is supported for the individual tenant. So it's everything when you do change master, as you said, or change the domain ID, so on, that will happen on the global level. That's how it works.
Yeah, so the idea is that if you want to have replication, you can go to a SaaS provider and say, I want to have replication from here to here, then you set it up. So the tenant can do that because...
So just like you said, the InnoDB buffer pool will be shared between everybody. The same way replication will be shared by everybody. I think that's
except in the case that if you replicate from one catalog to one premise, we need to filter everything that is not your domain ID to the other place because we don't want to share other people's data. So there is a little bit of work on that, but
the bin log will be shared.
Or no, we can't send the bin log.
I mean, they will use the same bin log on the master
Yes,
or bin log.
but
Send the data,
So the catalog server doesn't have one bin log. But I think it's much more interesting to have for the SaaS provider to be able to have a backup of something that is from outside inside. And for that we don't need to do anything. It should just work. So does the Lisa guys have anything to say? This will change your business totally and you will really want to support the foundation with this. I know that we can talk about the money later.
So I had a question. You mentioned like the server starting up in catalog mode. Is it like an exclusive, either you have catalogs enabled or you don't, and like either?
Yes, because the directory structure is different.
Yeah. So anyone who did have the old directory structure, if they want to use catalogs, they have to migrate to it?
Basically, you can just move the directory inside the catalog in Super. No, we need to do clean shutdown, so because it has a different InnoDB. So InnoDB tables themselves can be moved if you do a flash table for export. Then you can move those. So basically, it will be possible to do that. We plan to create tools.
Possible but very difficult.
Sorry?
Possible but difficult if you have to move individual tables.
I think it's nothing you can do in a week.
And what are your plans for the people who do have the databases with dots in their names?
In that case, because the dot is only used when you connect. As long as you connect with any other options, it will work.
I think it would be just sensible to require a client change because a database name is extremely easy to change. That's essentially something, a configuration file thing. And that if you have a software that you can change the database name, probably.
just use MariaDB minus catalog and gave the name there.
That's okay. Yeah, or buy Banky, we'll get Banky or do something, I got something.
And also we have, I didn't put here, we also need to have MaxScale to support this.
I got Jira's opening while you're talking.
But if there's no more questions, then I just have to say thanks for the end of a great conference. Thank you.
So Monty set the expectation that he will be able to continue forever, but that's the end of time then now. So thank you also from my side for a great MariaDB ServerFest. We will post this and notify you afterwards where you can continue the discussion over Zulip and see the presentations and all of that. So thank you. And a couple of concluding notes then for the MariaDB Foundation staff in a short while. Anna will say a couple of words.